ओके, पेपर 2 2017 का। चलो फिर स्टार्ट। Okay, the equation of plane passing through the point 1 and perpendicular planes. Okay, this and this is perpendicular to these two planes का क्रॉस प्रोडक्ट निकालो। क्या है हमारे planes 2 1 -1 oh okay -2 crossed with 3 -6 -2, right? Is that the thing? -6 -2 I mean perpendicular to both of these planes, that just means कि उसका जो vector है, it's like wait a second. Okay, the plane is perpendicular to those two, which means वो कुछ भी एंगल पे होगा and it's like perpendicular, right? Okay, yes, it's just this thing, of course, उसका क्रॉस प्रोडक्ट निकालना है। 2 1 -2 crossed with 3 -6 -2, which is क्या हो जाएगा, just -2 फिर +12, then for this guy just -6 and negative is just, well wait a second, it should be -2 -12 यार मैं स्टार्ट से गलतियां कर रहा हूँ। This is what -2 negative of +12 is just -12 और यहाँ पे क्या आएगा -6 and negative of -4 which is +4 और यहाँ पे just -12 and -3, right? Okay, cool, which is -15 फिर यहाँ पे just -2 and यहाँ पे -15 as well, which is like okay, so 15x plus 2y plus 15z, that's equal to 30 plus 2, right? Because 1 1 1 is 32, yeah। इसमें 14 दिया है इन लोगों ने, इसलिए मेरा गड़बड़ हुई हुई। ओह दैट्स 14 और इट्स लाइक पे 14 चाहिए एंड यहाँ पे 14x प्लस 2y प्लस 15, आई बिलीव अब मेरा करेक्ट है, दैट इज इक्वल टू व्हाट, राइट, दैट इज इक्वल टू 31 बिकॉज एक कम, यस। सो सी इज द आंसर, राइट? 37 का सी, ओके। नेक्स्ट क्वेश्चन 38, लेट O be the origin and PQR be arbitrary triangle and the point S is such that ये चीज, okay, so P vector times Q vector, so PQR is an arbitrary triangle, S is यानी 3 points है बस, S is the point such that this happens, triangle PQR has S as its whatever, okay। क्या ये P vector dotted with Q vector, so P vector dot with Q vector plus R vector dotted with S vector is equal to R vector dotted with P vector plus Q vector dotted with S vector, okay, is also equal to Q vector dotted with R vector plus P vector dotted with S vector. This is kind of weird. I mean, these are just values though. So, okay, think about it. What can you do with this thing? अगर मैं S vector common निकाले कुछ subtraction वगैरह कर पाऊँ, that would be really awesome, right? अच्छा, यहाँ पे P vector minus R vector you can do, right? Okay. So कोई भी दो equation को पकड़ लूँगा and let's see what happens. इससे P vector common निकल रहा है, P vector times Q vector minus R vector plus, oh, it should be Q vector dot S vector, right, over there? Yes. Okay. फिर इसमें से S vector common निकला is just R vector minus Q vector is equal to 0. This is basically what this is like, Q vector minus R vector times P vector minus S vector is equal to 0. So either other triangle that just means Q vector minus R vector is definitely not 0. So it's dotted with P vector minus S vector equal to 0. So this is perpendicular to that, but then Q vector minus R vector lies in the plane of this thing. Okay, interesting. But then ये सभी के लिए होगा नहीं? Oh, so like for each of these guys is perpendicular to this guy. Huh, where does that happen? I mean, तीन अलग अलग पॉइंट्स और वो तीनों से वेक्टर हमारा परपेंडिकुलर है। Wait a second. Okay, Q vector minus R vector is along the side QR, and then P vector minus R. Okay, समझ रहा हूँ. It's the ortho center. It's the ortho center. It has to be the ortho center, right? So D is the answer 38 का. Okay, next. Because हाँ मतलब ऑर्थ सेंटर होगा या फिर नहीं, ऑर्थ सेंटर ही होगा और कुछ नहीं हो सकता। ओके, y इक्वल टू y ऑफ x satisfies this equation, ठीक है, then and y of 0 equal to square root of 7, then y of 256 is equal to, okay, this differentiation 8 square root of x 9 जो भी है dy upon x दिया हुआ है, ठीक है ना, and y of 0 equal to square root of 7, y of 256 कितना है, ये सब x का है, okay, and it's dy upon dx, oh it's just, this is kind of not good. So what's dy upon dx? Dy upon dx is, this is weird. Let's try it out. So क्या नीचे जैसा आ रहा है square root of 4 plus square root of 9 plus square root of x, right? और ऊपर ऊपर कुछ भी नहीं आ रहा है. ओके दिस टाइम्स सो 1/8. ओके समझ रहा हूँ, मैं समझ रहा हूँ. स्क्वायर रूट ऑफ 9 प्लस स्क्वायर रूट ऑफ एक्स, well 2 टाइम्स ऑफ दैट बेसिकली. यहाँ पे 2x डाल दो, यहाँ पे 2 डाल दो, राइट. टाइम्स ऑफ 1/, सिर्फ square root of x. Okay, just 2 square root of x over there explains it. Yeah, so this is just the derivative of square root of so y is square root of 4 plus square root of 9 plus square root of x and plus some kind of constant. And then what you're saying is y of 0. Jab ye 0 jaga just square root of 4 plus 3 is like, okay, yeah, so c should be 0 in that case. Okay, then y of 256, just put x to 56, what do you get? Yep, 16 aega, so just 25, 5 plus 4 is like 9, square root of 9 is 3. So a 39 ka a, easy hai. If real to real function price difference was such that f double dash is bigger than 0 for all x belonging to real and f of 1/2 equal to 1/2, f of 1 equal to 1, then f double dash of x is bigger than 0 for all x belonging to real, and this happens. That's kind of weird. Well, the f dash is always positive, well, increasing throughout, right? That's what you're saying basically. So f dash is always increasing, f of 1/2 equal to 1. Oh, that's kind of weird. Then, and f of 1 is given, ठीक है. f dash of 1 के बारे में बोल रहे. Okay, Rawls theorem kind of. Yeah, okay. ठीक है ना. So 1/2 or 1, 2 points. Okay, yeah. At that point, f of, okay, just 1/2 and this thing is 1. Yeah. And f double dash is always positive, so it should make it's upward curvature. You get the thing. Yeah, so like it has to be like this, right? Yes. Slope कहीं ना कहीं तो ऐसा होना चाहिए in between that somewhere, right? Of course, initially positive raha, तो it's gonna reach that at some point, of course. हाँ, और वो स्लोप कहीं ना कहीं इक्वल तो रहेगा ही. Okay, we want what? F dash of 1, right? Oh, like, okay, f dash of 1 is definitely bigger than ये वाला slope, which just happens to be 1 minus 1/2. Okay, वो 1 है. So f dash of 1 is bigger than 1, right? That's what we think. So D looks correct. और क्या है? Bigger than 0, than, I don't know. D looks correct. 40 answer D. Just for the shape. Yeah, उसका जो shape है वैसा ही होना चाहिए ना. Exactly. Next question. How many 3 to 3 matrices with entries from 0 to 1? I mean, you can always do like integration कर दो कि f dash of 1 is bigger than f of x throughout this thing, f dash of x, uska integration, and then just you get a thing. Okay. Next 41. How many 3 by 3 matrices are entries 0, 1, 2, 3 are there, so for which the sum of the diagonal entries of m transpose m is 5. M transpose m. देखा सा लग रहा है क्या? M transpose m. अगर उसके रो वेक्टर्स ए वेक्टर बी वेक्टर ओके ए बी सी ऐसे तुम्हारे रो वेक्टर बन जाएंगे. एंड देन यहाँ पे जो तुम्हारे यहाँ पे तुम्हारे कॉलम वेक्टर्स थे नहीं, ए वेक्टर बी वेक्टर सी वेक्टर. सो पहले कॉलम वेक्टर का क्या होगा? जस्ट या सो बेसिकली ये हो जाएगा ना. इसका जस्ट ए स्क्वायर, फिर यहाँ पे ए डॉट पी, फिर यहाँ पे बी स्क्वायर और यहाँ पे सी स्क्वायर, व्हिच मींस वेट इज दैट थिंग, वेट अ सेकंड. ओ या ओके. सो जो तो उसके रो वेक्टर्स रहेंगे उनका जो स्क्वायर आ रहा है ओके यहाँ पे आ रहा है, राइट. Sum of the diagonal entries. Oh, but okay, like a square plus b square plus c squared equal to 5. That's all it's basically saying. And 3 by 3 entries is yeah, okay. 0, 1, 2. Using those, you have to form the vectors. And then a square. It's like उसके जो सारे जो m के एंट्रीज है सबका तुम्हें स्क्वायर करना है बेसिकली, राइट? एग्जैक्टली. आई मीन लुक एट दैट. इट्स जस्ट उतना ही बोल रहा है नहीं. Wait, is that the same or what? Wait. Right, that is the thing. It's just अबे इसको रहेगा फिर यहाँ पे नीचे ए भी आएगा. Yes. It's got to be the thing. So ये क्या बोल रहा है कि तुम्हारे जो एंट्रीज का स्क्वायर है सबके स्क्वायर का सम दैट्स इक्वल टू 5. ओके, मॉडुलो 5 इसका स्क्वायर जस्ट 0, यहाँ पे 1 आएगा, यहाँ पे -1 आएगा बेसिकली, राइट? एग्जैक्टली. ओके. एंड कितने एंट्रीज हो गए? 9 एंट्रीज चाहिए. सो दिस हैपेंस. हाँ, जीरोस तुम कितने भी डाल दो फर्क नहीं पड़ता नहीं. या ऑल दैट मैटर्स इज लाइक तुम 1 और -1 जो है उनको तुम इक्वली डिस्ट्रीब्यूट करो समवेयर. हर 1 के लिए तुम्हें एक ना एक नेगेटिव मे सम काइंड ऑफ रिकर्शन और समथिंग. इसमें 9 प्लेसेस बोल सकते हैं अपन. यस, 9 प्लेसेस है, उनमें तुम्हें ये 3 इंसर्ट करने से सम स्टिल क्या हो? 5. Okay, okay. It's kind of weird. But there must be 9 places, right? So how does that even make sense? Uh, some 5 which I guess we just have to do it by hand, huh? So, okay, I guess. This. Okay, thing 5. Maximum कैसे करना है इसमें 9 हो गया राइट ओके इट्स लाइक 9 minus 4 is equal to 5 और क्या होता है इसमें number of ones is like at max 9 हो सकते हैं oh you can't have 9 because फिर तुम्हारे पास है okay that doesn't make sense right so that is not possible फिर क्या 8 हो सकते हैं शायद से so 8 minus 3 लगने वाला है once again not possible because 8 plus 3 already 12 11 हो गया फिर 7 minus 2 ये 7 and 2 9 है सो पहली पॉसिबिलिटी आती है कि पास में 7 वंस है और 2 नेगेटिव वंस है इक्वल टू 5 ओके और क्या रहेगा व्हिच मींस इसका राइट सो यस 7 वंस एंड फिर उनको अपने को परम्यूट करना पड़ेगा नहीं एग्जैक्टली exactly. और लाइक चूज करना पड़ेगा कि कितनी जगह रहने वाली है और समथिंग लाइक दैट ठीक है ना सो क्या 9c7 एंड देन the remaining part रहेगा और you just use the multinomial so just 9 factorial upon 7 factorial 2 factorial 0 factorial okay awesome और क्या हो सकता है some kind of like polynomial generating function for this thing huh it's getting weird very weird actually whatever just चलते जाओ ठीक है 6 minus 3 हो सकता है shit नहीं 6 minus 1 हो सकता है नहीं yeah okay so 6 और मतलब 6 once आए then you have to do this thing okay right I mean I was trying to understand what's happening ठीक है ना so of course हम 4 ones वगैरह नहीं रख सकते because that doesn't make sense so 6 minus 1 or just have 5 plus 0 okay cool 6 minus 1 we just have 9 factorial upon 6 factorial 1 factorial and then remaining part is just 2 factorial okay और इसके लिए क्या होगा 9 factorial upon 5 factorial 0 factorial and then remaining part is 4 factorial got it let's calculate it's like 97 okay ठीक है ना so 9 times 8 upon 2 right which is like 36 plus ye cheese which is 9c4 9 times 8 times 7 times 6 upon 4 times 3 times 2 4 और 2 का just ये 2 बन गया यहाँ पे just like 9 times 7 is 63 that times of 2 is just 126 okay फिर finally ये चीज but that we did actually just want this thing 1 factorial is 1 awesome which is basically this thing 9 factorial is like what 9 times 8 times 7 okay that upon 2 right so 9 times 4 times 7 which is 63 times 4 हाँ ठीक है 60 times 6 कर डालो so कितना है just 8 1 का add on to 36 like 37 so 378 plus 36 it seems which is 412 or some 414 sorry so 41 okay that's not there I don't know so कैसे करना है that case right हाँ ठीक है let's move on okay s be equal to this thing for k equal to 1 2 3 1 2 3 5 let n be the number of subsets of s each containing 5 elements out of which exactly k are odd and n1 plus n2 and 5 is equal to for k is equal to 1 2 till 5 let nk be the number of subsets of s each containing 5 elements huh look at it लास्ट वाला अपन ने सब कुछ करेक्टली किया था नहीं यस यस आई थिंक अपन ने करेक्टली किया था तो फिर मेरा गलत कैसे हुआ इसके तो यानी काफी बड़े नंबर आ रहे दैट शुड नॉट बी द थिंग राइट so what is the diagonal entries of m transpose m right that should be 5 then I did the thing look यहाँ पे squares आएगी oh shit ये अपन ने मॉडलो 5 किया we should not have okay okay समझ रहा हूँ मैं huge mistake right yeah huge mistake okay तो the only way is कि तुम 4 plus 1 करो या फिर 1 plus 1 plus 1 चाहो ओके 5 बार राइट सो 4 plus 1 यानी कि क्या एक 2 रहेगा एक अपने पास में 1 रहेगा बाकी सारे सारे 0 रहेंगे राइट या ऑफ कोर्स सो वो करने के लिए क्या आपके पास 9 जगह है जस्ट you know 9 factorial upon 1 factorial 1 factorial and then well yeah which is just 7 factorial right that's the thing that which is just 9 times 8 yes 9 times 8 positions so like okay that's just 72 plus और लास्ट रहेगा कि 5 1 आ गए which means just 9c5 So 9 times 8 times 7 times 6 upon, okay, I think, yeah, okay, 4 3 2, राइट। तो ये जस्ट मर गया है, जस्ट बेसिकली यहाँ पे 2, यहाँ पे क्या था 9 + 2 126 which is 198 or something. So D's answer 41 का B 42, that has equal to this thing for k equal to, okay, let n k be the number of subsets of S each containing 5 elements out of which exactly k are odd, then n1 plus n2 till n5 equal to, n k be the number of subsets of S, इसके subsets k equal to 1 जो भी है, right, which containing 5 elements out of which exactly k are odd. So for example n1 में एक में odd element चाहिए and then got it. Then wait, you want the number of subsets, right? Oh, okay, got it. So like क्या बस एक element को, okay, that's not that hard. Yeah, wait, तो 5 odd elements का मतलब क्या? अच्छा 0 odd elements हम कर सकते हैं क्या? I guess yeah. 5 odd elements, कितने इसमें odd elements है? 1 3 5 7 9, 5 exactly, this is the maximum value. n0 इसमें ऐड करो और सब्ट्रैक्ट करो। n0 इसकी तुम्हारे पास में एक भी ऑड एलिमेंट नहीं है, which means तुम्हारे पास क्या क्या 2 2 4 6, ओके, ये तो जमता ही नहीं है, तो दैट्स 0 एनीवे, ठीक है ना। तो ये दिस इज लाइक द टोटल नंबर ऑफ वेज ऑफ हैविंग सबसेट ऑफ 5, राइट, एग्जैक्टली, which is like what, तुम इसमें डालो ना डालो, ओके, लाइक 2 पावर 5, राइट, नहीं नहीं 9c5, सॉरी, इसमें लिमिटेशंस रहेगी ना, right, of course, so just 9c5 which is 9 times 8 अपन कर सकते हैं 126, we already know, so D is the answer for Puka. 43 is 3 randomly chosen non-negative integers that is, satisfy this equation, that probability that z is even is, okay, non-negative integers satisfy this equation, probability that z is even, oh god, okay, z is even, huh, probability of that guy, randomly chosen, are found to satisfy this, wait, what, तुम उनको randomly choose किया नहीं, okay, it's like probability that they will satisfy this, which is actually very minuscule anyway, and yeah, because the randomness, like every case has a similar chance, ठीक है ना, then it's easy probable, you can do this thing, probability of that z is even is whatever, if z is even then x plus y has to be some kind of even number, okay, right, सारे cases equal probable रहेगा नहीं, yes, so total number of even cases about only the number of odd cases, okay, suppose even है तो कितने cases आने वाले हैं, मतलब okay, let's just start off at I don't know 0, so 0 plus x plus y equal to 10, तो how many ways you know, so split कर पाओ, it's like 0 and 10 तुम split कर सकते हो, and okay, like partition कर रहे हो, right, all the number of ways that you can actually partition 10, so, yeah, which is what 0 से start कर रहे हो till obviously 10, so like 11 फिर plus next क्या आएगा, जो तुम्हारा z 2 हो जाए just 8, तो like plus 9, फिर तुम्हारा z क्या होगा, या कीप ऑन गोइंग, एंड देन नीचे जस्ट नीचे क्या आएगा, इट्स जस्ट वो 1 वाले किसी से लेने वाले नहीं, या जस्ट 11 प्लस 10 प्लस 9 चलते जाओ, और यहाँ पे जस्ट सारे ऑड नंबर्स ऑफ कोर्स, 7 प्लस 5 प्लस 3 प्लस 1, और यहाँ पे सारे, या just like what नीचे जैसा देगा 11 times 12 upon 2, ऊपर कितने ऑड नंबर से 1 2 3 4 5 6 6 का स्क्वायर, गॉट इट, सो व्हाट, ऊपर जस्ट किया 12 मर गए, बढ़िया, I mean it's 12 upon 11 is the probability, wait what, no sorry 6 upon 11, right, which is B, so what if you answer B. Next question 44. 44 is section 27 questions, each question has blah blah blah, if g of x is equal to this thing, then multiple choice, right, one or more than one, और ये क्या था, सिंगल करेक्ट था कि क्या, only one, okay, right, this was single correct, this was multiple correct, ठीक है ना, g of x equal to this thing, then g dash of pi upon 2, g dash of negative pi upon 2, whatever, g dash क्या रहेगा, sin inverse of t, god, why that, sin inverse of t, huh, pi upon 2 you are saying though, just put that over there, sin inverse of 2x when it's like pi upon 2, it's kind of not so easy to do, right, yeah, I mean वो इंटीग्रल खुद ही थोड़ा सा अजीब नहीं हो जाएगा, because right, I mean it's just some function, we don't really care, okay, so what do you get, जी डैश इज सर देखो पहले पाई अपॉन 2 पे वैल्यूज क्या आएगी, यहाँ पे आएगा पाई अपॉन 2 which is 1 and then यहाँ पे 0 आ जाएगा, राइट? सो लाइक इंटीग्रेशन फ्रॉम या सो अपना जो आ जाएगा लाइक ओके 2 साइन इनवर्स ऑफ 0 माइनस 1 साइन इनवर्स ऑफ ओह शिट बाय द वे ये डेरिवेटिव भी लगेगा इसमें, ओके सो क्या साइन इनवर्स ऑफ sin of 2x and then derivative which is 2 cosine of 2x. So 2 cosine of 2x is okay, whatever. Right, of sine inverse of sine of 2x. फिर minus ठीक है just cosine of x sine inverse of sine of x. So at pi upon 2 क्या हो रहा है, just 2 cosine of pi which is just negative 2 and then sine inverse of 0 which is just 0 तो मर गया, बढ़ गया. And then this so ये अपने आप 0 हो चुका है, so it's just 0, right? Yeah, at sin x it will just be of course that makes sense. It's just going to be gone, right? Because clearly x is 5.2 ये okay that's just 5.2 ये चीज मर गई. So yes this is just 0. Okay at negative pi upon 2 करना है अपने को फिर. So at negative pi upon 2 sine of negative pi is still 0 यार. This is getting weird. I mean it's still 0 तो हाँ वे इनमें से कोई भी काम नहीं करता है यार, right? I mean the way this function works is कि तुम साइन इनवर्स ऑफ वैल्यू देखते हो, तुम ये नहीं देखते हो कि ओह गॉड या ये तो हमेशा 0 हो जाएगा, ये हमेशा 1 रहेगा, बट तो 5.2 की नेगेटिव 5.2 तो डेरिवेटिव 0 है. ओके कूल, नेक्स्ट क्वेश्चन. अल्फा बीटा भी नॉन सो 44 का आंसर 0 रहेगा ऑल द टाइम. 45 अल्फा बीटा नॉन जीरो रियल नंबर सच दैट दिस हैपेंस देन इज द फॉलोइंग इज आर ट्रू. सो टू काइंड्स ऑफ कोसाइन अल्फा कोसाइन अल्फा प्लस कोसाइन अल्फा मुझे इक्वल टू ओके 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 आई थिंक आई नो कहाँ पे जा रहा है. सो सी अल्फा फिर नेगेटिव 2 चाहिए ना, 2 कोसाइन अल्फा ओके प्लस 2 टाइम्स सी बीटा minus 2 because clearly हमें negative 2 आएगा, right? It's equal to what? 1 oh god right अपने को एक्स्ट्रा टर्म क्या ऐड करनी है, यहाँ पे negative 4 ऐड करना है, so like 1 minus negative okay just negative 3, right? And when does that actually happen? We don't know. Ooh, we don't know, huh? But ये right, so these are actually just free variables. इनकी maximum values 3 होनी चाहिए, right? Oh, something's not right about this. यहाँ पे negative 4 चाहिए and then just do that guy. Then 2 cosine alpha and then plus 2 cosine beta. Yes, and just negative 4 over there. And that should actually work out. So यहाँ पे just negative 3 आएगा in any case. So the following is all true. Oh, ये सब क्या है? I was not expecting this. इसमें कोई इससे स्मार्ट केस अपन नहीं कर सकते, नहीं? इनकी मैक्सिमम वैल्यू तो 3 आएगी. Wait, यहाँ पे negative 2 है नहीं? इसकी और ये पूरा negative चाहिए अपने को. So okay. 1 times negative 3 and negative 1 उसके बीच में भी कहीं ना कहीं तो हो सकता है. सो हाँ क्या और क्या फिर अब क्या है, tan of alpha upon 2 plus 3 tan beta upon 2 equal to 0. This is not going to help. You can use that over there, but then in the end does not actually help. Tan beta upon 2 equal to 0 square 3 tan of alpha. This is weird. So you want tan alpha upon 2 upon tan beta upon 2, right? Okay, let's try it out. So yeah, just 1 minus t square upon 1 plus t square and then plus 2 or something, right? Because just what 3 3 plus t square upon plus 2. नहीं ये हेल्प तो नहीं कर रहा है किसी तरह से. So हाँ no, not helping. Even at that position doesn't help. Guess something और तरीका है, just put that in there. We'll see what happens. Exactly. That's 1 over there. What is this? पे 2 आएगा, इसको मैं ब्रेक कर सकता हूँ. Just not worth of, yeah, it's not worth doing, right? ठीक है, like what 3 plus tan square alpha upon 1 plus tan square alpha that times of ये चीज होती है -2 which means कि यहाँ पे just -2 like negative -1 and negative 3t square. Okay, got it. So ठीक है ना, just 1 plus 3 tan square beta upon 1 plus tan square beta, that is equal to 3. That makes sense. So चलो 3 plus 9 tan square beta upon 2. उसका you know what, it's gonna call it capital B. Just 3 plus capital A upon 1 plus capital A times 1 plus 3 capital B upon 1 plus capital B equal to 3, which means कि 3 plus 9B plus A plus 3AB is equal to 3AB plus 3A plus 3B plus 3, right? Yeah, वो 3 तो मरा, ये 3A भी मर गया. What do you get? Just get 2A equal to 6B. So basically like A equal to 3B, मतलब कि क्या, tan of alpha upon 2 equal to 3 times of tan of beta upon 2, not square root 3 or not square root of 3. Oh, अच्छा ये square में आएगा, right? Okay, tan square alpha upon 2, right? Which means tan, okay. Wait, ये multiple choice है ना? हाँ, I think R की जगह पे may be true बोलना चाहिए था. So it's either C or it's, yeah, it's either C or it's B. No, this is not correct. This is not correct. Okay, A and C. Next question. 45 का A and C. Next. 46. Okay, if f real to real differential function such that f dash of x is bigger than 2fx for all x not real and f of 0 equal to 1, then okay, differential function such that this happens and f of 0 equal to 1, then f of x is increasing in 0 to infinity, fx is bigger than e power 2x in 0 to infinity, fx is decreasing in 0 to infinity. So initially 1 था ना, like okay 2 है यहाँ पे. Okay, got it. So just you know, right, it's like natural log of f of x because so initially positive, whatever, right? Derivative of this guy, like d upon dx of natural log of f of x is bigger than 2, which means that natural log of f of x is bigger than 2 e power x plus some kind of constant, right? Initially f of, right, at 0 is just 1 to वो 0, okay, that's cancelled. So यहाँ पे तुम negative 2 put कर सकते हो, which means that no 2x यहाँ पे sorry, वो 0 हो गया, which means okay चलेगा. So natural log of f of x is bigger than 2x at all times. That's what you're saying. Okay, basically f of x is bigger than e power 2x. Got it. Okay, yeah, so C is correct. 0 to infinity was 0 by 1 है. F dash, well no, f dash of x is actually, wait, the derivative is also, I mean f dash क्या होगा? Well, that's bigger than 2f of x, right? Okay, which is already just bigger than 2 e power x. Okay, that works out. So ये तो गलत है. It's decreasing in 0 to infinity, wrong. It's increasing in 0 to infinity, yes, and C is correct. So 40 is the A and C. Next question, 47. Let f of x be equal to this thing, then okay, 1 minus क्या है ये चीज, x and then 1 plus 1 mod of 1 minus x. Okay, cosine of 1 upon 1 minus x for x not equal to 1, then limit x tends to 1, right? ठीक है ना? First we'll just say that, oh okay, wait a second, we'll have to make cases. First case, x is 1 plus h, ठीक है, or just put that in generals like 1 minus 1 plus h upon, okay, that times of 1 plus mod h, okay, upon mod h, right? Yeah, which is like what, it's just 1 minus of ये क्या जगह 1 plus h plus mod h plus h mod h, okay, on mod h, which is ये तो मर गया basically this thing, right? Negative h, ठीक है ना, we got it. वो 1 को हटा दो just this thing. So case 1 h positive है, then ये क्या जगह negative 2, right? So this limit is just negative 2. Oh, क्या है cosine? Okay, cosine of 1 upon h, huh? So like h tends to 0, तो ये चीज को infinity approach कर रही है, that does not make sense. Right, so like x tends to 1 plus, then this might make sense because ये random है. Okay, नहीं, that won't make sense. X tends to 1 minus, this would make sense. I guess you could say so, right? I mean, think about it. उफ, वहाँ पे नेगेटिव एच आएगा, like just negative, वो फर्क नहीं पड़ता, it goes random. So ठीक है ना, H should be negative, मतलब कि it should be 1 minus, then this might just work out. Yeah, H should be negative. That makes sense. So when it's like 1 minus, then this will just become, yeah, just H cosine of 1 upon. No, it's like 0. That's 0, of course. So A correct and limit extends to 1 plus, that was not exist. So A and B. Next question. 48. If f x equal to this thing, then cosine 2x negative cosine x sin x. Are you serious? अच्छा cosine 2 हर जगह पे cosine 2x डाला है. Oh, that's new. So तुम इसको ब्रेक करोगे like 2sc over there. तुम s को डायरेक्ट निकाल नहीं सकते for some reason. ठीक है ना? We just have to think about something else. दो इसमें cosine 2x है. Subtract this from there. What do you get? Cosine 2x negative cosine x sin x. I should say this thing. राइट यहाँ पे 0 आएगा, पे नेगेटिव 2 कोसाइन x, फिर यहाँ पे 0, यहाँ पे कोसाइन 2x, जिसको साइन x ओवर देयर, यहाँ पे साइन x है, यहाँ पे साइन 2x है, यहाँ पे नेगेटिव साइन x है, यहाँ पे कोसाइन x है. ऑलराइट, ऑसम. अब क्या प्रॉब्लम, जस्ट ब्रिंग आउट कोसाइन x और समथिंग. ठीक है ना, वो नेगेटिव 2 कोसाइन x वहाँ पे चला गया. ओके, ये तुम पूरी रो कैंसिल कर सकते हो. दैट्स ऑसम. जस्ट नेगेटिव, right. Okay, that's pretty easy. So just negative positive, it's like plus 2 cosine x, and then which is just cosine 2x cosine x minus sine x sine 2x, which happens to be cosine of 3x. So 2 cosine x cosine 3x. F of x is equal to 2 cosine x cosine 3x, which is like cosine of a plus b is 4x minus cosine of 2x. Yes. F dash of x equal to 0 at exactly 3 points in negative pi to pi. Okay, what's f dash like negative? Oh, negative I'm भूल जाओ. Just what do you get, like 4 sine of 4x. अच्छा वो तो 2 आएगा anyway. This 2 sine of 4x equal to sine of 2x is when this is equal to 0, which means you can change this like 4 cosine of 2x is equal to 1, which means cosine of 2x equal to 1 upon 4. That should be the thing. Okay, very weird. 1 upon 4 now. ठीक है, that's the thing. So when does that happen? In कहाँ से कहाँ, negative pi to pi. Yeah, this happens at 2. Wait, 2 pi goes from, oh, it's 2x over this. Like negative 2 pi से 2 pi पे जा रहा है, which means 4 बार, नहीं 4 बार. Yes, so it's like at 4 times. So a not 3 points, it's at 4 points. Right, so I think B is correct. 48 का. और क्या है? F means its maximum at, unless it's 0, then that would make sense, but it's not. It's not. I don't know. Okay, और ये तो एक possibility, और दूसरी possibility कि sin 2x खुद 0 हो जाए, which, okay, that makes more than 3 points. Okay, fx equal to, okay, fx attains its maximum at x equal to 0. And 0 तुम्हारा डेरिवेटिव 0 है, yes, and तुम्हारा डबल डेरिवेटिव कितना होगा? Okay, let's see. So 4 4 is 16 sine, okay, 16 cosine of 4x minus, oh नेगेटिव आएगा ना. Okay, second डेरिवेटिव just नेगेटिव बाहर आ गया है, just cosine of 4x minus of just 4 sine, okay, cosine of 2x, तो 0, just let's go like 12, negative 12 नेगेटिव वैल्यू है, which means तुम्हारा maximum रहेगा. Yes, so C is correct. Okay, C is correct. Next question, 49. 49 is if the line x equal to alpha divides the area of this region into 2 equal parts, then okay, this line divides this region into 2 equal parts. क्या है ये? X5 belongs to real squared. Okay, x cube is less than or equal to y less than or equal to x. Okay, x is between 0 and 1. ठीक है. At 1 these become equal, of course, so then y will, okay, that makes sense. So x equal to 0 will be same होगा ना? Exactly. So at 0 it's just equal, at 1 these are equal. थोड़ा सा बड़ा ग्राफ ड्रॉ करता हूँ. 0 over there, यहाँ पे just 1 पे, yes, it will just be like ऐसा. Alright, so if x equal to alpha divides the area of this region into 2 equal parts, okay, वो ऐसा हो जाएगा. Got it. So that's where this will, okay, if x equal to alpha, then what's y? Wait, x equal to, okay, it's not this thing, actually this thing, right? Yeah, इस रीजन को तुमने 2 इक्वल पार्ट्स में डिवाइड कर दिया. ओके, दिस इज काइंड ऑफ वियर्ड, व्हाटएवर. So what? Integration from 0 to alpha of x minus x cube is equal to integration from alpha to 1 of x minus x cube, right? That should happen. Okay, then alpha kya hai, right? That's what you want to figure out. Okay, let's do it. So क्या होगा? X square upon 2 integration is alpha squared upon 2 minus upon 4 alpha power 4 upon 4. Well, actually 2 times of this, right? Okay, because of that is equal to जब से 1 to just 1 upon 2 minus 1 upon 4, I mean just 1 upon 4, of course. So what do you get? Just get alpha squared plus alpha squared, so alpha power 4 upon 2 is equal to 1 upon 4, or like, okay, or like but I have 4, just get 4 alpha power, oh shit, 2 alpha power 4, what am I doing? Minus 2 minus 4 alpha squared, उधर भेज दिया. This is stupid. 2 से 1 क्या करो, no? Yes. What do you get? Just alpha power 4 minus 2 alpha squared plus 1 upon 2 is equal to 0, right? Yeah. So alpha squared minus 1 plus square is equal to 1 upon 2. So alpha squared has to be 1 plus 1 upon square root of 2 or 1 minus 1 upon square root of 2. दोनों चलते हैं, okay, whatever. Then alpha के बारे में बताओ. Alpha is between 0 and 1 upon 2. It is bigger than 0 for sure, because yes, and it's less than 1 upon 2, huh? Actually, it depends. यहाँ पे दो possibilities आ रही नहीं. Oh, ये तो 1 से बड़ा है, that can't happen. So alpha has to be just like alpha square is just 1 minus 1 upon square root of 2. Like alpha is square root of square root 2 minus 1 upon square root of 2. Let's see. That won't work. Okay, whatever. Right? But that's the equation. Just about 4 plus 4 alpha squared. That's not 4. That's not 4 over there. Wait, am I dreaming or what? नहीं, इसमें 2 चाहिए ना. Okay, that makes sense. It's 2 alpha power 4 minus 4 alpha squared plus 1 equal to 0. So C is correct. 49 का C. और क्या है? Alpha between 1 upon 2 and 1. It's less than 1, yes. And 1 minus, okay. Is this like less than, is this bigger than 1 upon 4, you are saying? I guess so. It's like, it's asking 3 upon 4 bigger than 1 upon square root of 2. It's asking, is 3 bigger than 2 square root of 2? Yes, it is, because 9 bigger than 8. So that's right. B is correct or C is correct. Awesome. Next question. If I equal to this integral, then summation from k equal to 1 to 98 integration k to k plus 1 of k plus 1 upon x times x plus 1. Hey, that is partial fraction. ये क्या हो गया इनके क्वेश्चंस को आगे? Okay, k to k plus 1 summation from k equal to 1 to 98. Good thing it's not infinite series, which means कि अपन इसको अंदर ला सकते हैं, right? Yeah, only when it's infinite series does that actually make problems. Okay, right. Wait, oh shit, ये k पे dependent है. Oh, not good, huh? Not good. We just have to actually solve it. K plus 1, where 1 upon x minus 1 upon x plus 1 is integration is natural log of x upon x plus 1. Yeah. It goes from what to what? So like from k to k plus 1, nahin? Let's see just what you get. K plus 1 natural log of k plus 1 upon k plus 2 times k plus 1 upon k. Okay, not helping. Square is it? Now what do we do? You wanna, okay, summation of this thing. Oh, just want this to be less than or equal to some. Okay, understood. Wait, k to k plus 1. That's kind of weird. K plus 1 उसमें तुमने बाहर क्यों निकाला है, by the way? जो भी है, just want to sum this up from k equal to 1 to 98. Okay, yes. जो भी है. Actually, just you know what? K plus 1 equal to 2 to 99. So we'll just say k equal to 2 to 99. And then it's like summation of k natural log of k squared upon k squared minus 1, right? So k natural log of 1 upon 1 minus, yeah, I'm trying to understand क्या हो रहा है यहाँ पे, but it's still just weird. k तुमने क्यों सामने लाया हुआ है? And 99, huh? Oh, divided by 99. It's like some kind of integral, but we'll see. Okay, so it's approximately bigger than, okay. I think we know where it's going, right? Okay, natural log, okay, just a second. This can be written like this. It's just negative natural log of 1 minus 1 upon k square, right? That won't help. That just won't help. Natural log of k. It's an integral of the natural log something, right? That will never help. K to k plus 1. Natural log of 99. It's like तुम इसको sum कर रहे हो, but then उस particular range में इसमें k plus 1 है. It's like close to what x is. नीचे x times x plus 1, right? Basically that just goes from, so उस range में हमारा जो function है, so k plus 1 upon, right, this thing that just goes from what to what. K put करने में just k plus 1, okay, that's just like 1 upon k and it goes to k plus 1 तो put करोगे just wait, k put करने में क्या मिलेगा तुम्हें? Yeah, that cancels into k plus 1 put k plus 2, right, till 1 upon k plus 2, right? So approximately 1 upon k लिख सकता हूँ मैं इसको. Yes. So ये जो area रहेगा, it's this trapezium thing. What is this? This is so stupid. It's like at k, it's just 1 upon k. Right, this integration of 1 upon x dx, but then not quite. Right. At k plus 1, this should have been, okay, it's like 1 upon k plus 2. So it's थोड़ा सा छोटा रहेगा. It's like, right, your integral is actually less than this integral. So integration of 1 upon x dx from what? 1 to 98, huh? K start with that 1, so just, okay. I think 1 to 98 is a good thing to do. This is what? Natural log of x. Natural log of 98. Oh, k plus 1 tak, nahin? Yeah. So it's like less than of natural log of 99 most likely. So B looks correct. Take a B. और क्या है? I is bigger than 49 upon 50, less than 49 upon 50. Oof. 49 upon 50. ये वैल्यू कहाँ से आ रही है? Natural log of 99, is that close to this or something? 49 upon 50. What? So initially क्या है? Initially it's just, no, we want a very good approximation. Like, okay, तो ये तो 1 के पास में आ रहा है, नहीं? The natural log of 99, that's actually, so we just have to prove that's bigger than that, right? Yeah. So ये जो चीज़ है इसकी minimum value क्या रहेगी when it's just, yeah, when it's maximum. So at k is equal to 98, it's like 98 to 99 जाएगा, नहीं? Yes. So the last sum रहेगा, which is just 1. Okay, वो क्या होगा? It's just 99 natural log of 99 का square upon 99 square minus 1, right? It's getting out of hand now. Okay, and how many of these guys? This is just not making sense. Right, so उस value से it should be of course bigger than that throughout, right? So it's just bigger than that, of course. 100, यहाँ पे 98 आ रहा है, bigger than 1, we know that. So D, right? Take answer D. Much bigger, I believe. Next question. What is this? Paragraph 5. Okay. O be the origin and these are 3 unit vectors in the direction of the sides. These, okay. Q R X vector, okay. Unit vectors in the directions of these sides. Okay. Then OX, okay, let's do this thing. So what? P Q R. First you just want QR vector, so that's just X vector along that. Okay, फिर क्या है? फिर RP vector, so that's Y vector, and then PQ vector, which is Z vector. Okay, what do you want? OX vector. Okay, so X vector cross Y vector. Right? That's the area. Okay, yeah. Sign of P plus Q R. Okay, angle, right? That's the same thing as sign of angle R. Yes. उसका अपने को mod चाहिए. You do realize, acha, you unit vectors. Okay, you should have told me it's just hat, right? Okay. Then yes, it's just the sign of that angle, which is sign of r. So yes, A is correct. Sign of 2r, no. Sign of p plus r, no. No. Sign of q plus r, no. So A is correct. P1 ka A. Next, the triangle PQR varies, then the minimum value of this thing, cosine of p plus q plus cosine of q plus r plus cosine of r plus p. Okay, so it's like saying negative of cosine r theta. Those things. Minimum value होती है at equilibrium, which is when you have, क्या बोला था मुझे? Yeah, this should be like the maximum. Oh shit, ये क्या हो रहा है? Wait, what is happening? I don't know. Whatever. So क्या हो जाएगा इस सारे सारे 6 degrees is like 1 upon 2, so 3 upon 2. Yeah, negative 3 upon 2 is not the minimum value. कुछ और ऐसा जो कि इससे it can be minimum than that. No, so I think B is the thing. Right. Okay, cool. Yeah. For okay, PQ integers, alpha beta with the roots of this equation, where for not equal to, for n equal to this thing. Okay, if A, B are rational numbers and A plus B squared of 5 is equal to 0, then A equal to 0 equal to B. What? It's a fact. Of course it's a fact. Okay, PQ are integers, alpha beta be the roots of this equation. Alpha is not equal to beta. X are equal to x plus 1. That's like Fibonacci equation, isn't it? Okay, beta are the roots of this equation. PQ are just integers. For n equal to 0, जो भी है. Alpha, sorry, what an is equal to p. It's just the recursion god. Okay, it's just the Fibonacci recursion. I know that. मैंने 1000 बार ये solve करने में ये use किया हुआ है. Right? Okay. PQ is some kind of integers, right? Yes, okay. A12 is equal to what? Wait, तुम्हें दिया नहीं कि P और Q क्या है तो? हाँ. Roots of this equation where n. हाँ, but तुम्हें दिया नहीं है कि A12 क्या? Oh, doesn't matter because we just have to figure this out. It's just Fibonacci recursion, right? Yeah, x equal to, that's the characteristic polynomial of the Fibonacci recursion. और ये क्या है? Just उसका solution, of course. Right. So this is just equal to what? A11 plus A10, which is B. So 53 का B. 54, A4 equal to 2B, then P plus 2Q equal to what? A4 equal to 98. Okay. Then what's P plus Q? Oh yeah. Yeah. Guess you can. हाँ, इसको change करो ना पहले. Then what's A4? A4 can be like A. क्या है इसमें? हाँ, A3 plus A2, which is written as like A2 plus A1. Then equal to 0 से तुम start कर सकते, right? Yeah. Then you can write A2 as A1 plus like 3A1 plus 2A0. That makes sense. So what's 3A1? So तुम n equal to 1 put करोगे, then just, yeah, well, it's 3 times of alpha p plus beta q plus 2a, okay, 0, right? A0 is what? Just p plus q first. 2 times of p plus q. That's equal to what? 28. And what's p plus 2q, right? Exactly. Okay, so alpha plus beta is of form. Oh, you have to figure that out. 1 plus minus square root of b square is just 5. So, upon 2. Okay. So what do you get is p plus q upon 2. Right. So 3 upon 2 times p plus q इसमें आएगा. Okay, just make these. Okay, then that just means p minus q has to be equal to 0, right? Because of this fact. Yes. P and q are just got it. So तुम same कर सकते हो, which means like just alpha plus beta, which happens to be 1. So this is just what 3 p. This is called like q को p बोलो. What does it become? 2 से divide करो. Just get just 3 times of p plus 4p, because that's what it is. That's equal to 28, which means 7p. Okay, p equal to what? 3.7 is 4. Awesome. So p plus 2 gives us 3 times of that. 12. So that's D. 54 का D. Next question. ये हो गया physics, right? Because और तो थे नहीं इसमें. Yeah. Physics. अरे यार चल 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 Okay. Consider an expanding sphere of instantaneous radius r whose total mass remains constant. The expansion is such that the instantaneous density rho remains uniform throughout the volume. The rate of fractional change in density is constant. The velocity v of any point on the surface of the expanding sphere is proportional to. Okay, total mass remains constant. The expansion is such that instantaneous density rho remains uniform. Huh. Okay. Throughout the volume, the rate of fractional change in density. What do you mean by that? Instantaneous density remains uniform. Acha, acha, acha. Okay, okay. Understood. Right. The rate of fractional change in density is 1 upon rho d rho. Okay, d rho upon dt. That is a constant. Okay. In d rho upon rho, that's like proportional to r power negative 3 है ना ये. But rho thing was m upon that. Mass हमारा same है क्या? Expanding sphere of radius. This radius r. This total mass remains constant. Mass remains constant. M upon r. Yes. So this is like negative 3 dr upon r, right? And that upon dt. So just negative 3 dr upon just v upon r, right? That's what it is. That's some kind of constant. जो भी है. So the velocity of any point on surface r just v proportional to r, right? Exactly. So just a first concept. Of course, of course. I mean, look at this. This is pretty obvious. Next question. Consider regular polygons with number of sides n equal to blah blah blah. Okay, as shown in the figure, the center of mass of all polygons is at height h from the ground. They roll on horizontal surface about the leading vertex without slipping and sliding as depicted. The maximum increase in height of the locus of the center of mass of each polygon is delta. Then delta depends on n and h as increase in height. Wait, what? They roll on horizontal surface without about the leading vertex without slipping and sliding. Oh, that's just geometry, yeah. The maximum height, okay, of the locus center of increase. Oh, okay. Is delta. Then delta depends on n and h as. Okay. Nothing on it. It's like the angle bisector. हमारे पास में जो भी एंगल रहेगा वर्टेक्स का तो उसको हाफ करोगे सो हमारा हाफ एंगल थीटा बोल दो yeah, it starts off at that point. फिर इसको तो ऊपर ले जाते हो it's theta over there, right? So it's just like what this thing is just sine theta, right? So 1 minus sine theta times the radius, right? This radius, of course. What's theta by the way? So just pi upon n, I believe, right? और ये जो r value रहेगी, what's that going to be? Okay, delta depends on n and h as. Yeah. Oh, h अपने को दिया हुआ है. It's the same everywhere. Awesome. Awesome. Wait. So that means कि oh, using h you will have to figure this out, right? Okay, so what's the r value? So ये theta है. It's just h upon sine, right? So h upon sine theta. This thing is about h. That's that value, right? Which is like what h times of 1 upon sine theta minus 1. And just 1 upon sine of pi upon n minus 1. That explains it. Okay, cool. Not cosine. It's definitely not that, right? I doubt it's cosine. Wait, is it cosine? Tan square pi upon 2n. I messed up somewhere. It's probably sine, right? I mean, yeah, that's the thing for sure. So that is our height. Okay. So what's delta? It's just okay. Ye cheese. This is wrong. Delta is equal to h sine square of pi upon n. No. ये सारे गलत लग रहा है यार. Tan square pi upon. Okay, that's not this. Square कैसे आ रहा है इसमें? It's clearly got to be r, right? Yeah, ये length कितनी होगी? It's clearly just pi upon n in that sense. Oh shit, that's not pi upon n. It's different. Sorry. Pi upon n तो ये चीज होगी ना? Yes, that. Okay, that makes sense. So ये pi upon n and actually 90 plus that होगा, which means it's usually cosine over there. So okay, now ये क्या just so B is correct and that's it. So B is correct. Next question. Third is Photoelectric material having work function phi related with light of wavelength lambda. The fastest photoelectron has a d to the wavelength lambda. Changing the wavelength of the incident light by delta lambda results in change delta lambda in lambda t. Then the ratio this is proportional to what? Having work function phi naught related with the light of wavelength lambda. The fastest photoelectron has a d Broglie wavelength lambda t. H upon lambda is bigger than cool. अच्छा जो तुम emit कर okay got it right the a change in wavelength of the incident light by delta okay got it right चलो करते हैं hc upon lambda minus the work function this thing is equal to जो भी energy थी इसकी right which I mean yeah so अपना जो momentum था that was what that was h upon lambda d and what was like half mv squared or like t square upon 2m. So just sort of this guy's like h square. That's not what I thought this would be. But that's what it is. Huh? जो भी है just h square upon lambda squared of the photoelectron. Lambda p है कि क्या है d जो भी है. Okay, got it. So h square upon lambda square and नीचे just 1 upon 2m. Right. इसका डेरिवेटिव ले लेते हैं. Right. What do you get? एक h मरने वाला just get like negative c upon lambda square d lambda is equal to यहाँ पे वो तो कांस्टेंट है सॉरी h square upon 2m फिर इसका डेरिवेटिव which negative 2 upon lambda d cubed and then d lambda d got it so negative का है what do you get ये 2 वहाँ पे मर गया d lambda d upon d lambda that is equal to lambda d cubed times m upon h square. Oh, it's h, not h square. Okay. Right. और यहाँ पे c upon lambda squared. So lambda cube upon lambda squared. Lambda d cube upon lambda squared, which is b. Or yeah, that should be. So b is the answer. So answer B. Next question 4. Symmetric star-shaped conducting wire loop carrying a steady current I. Shown in the figure, the distance between the diametrically opposite vertices of the star is 4a. The magnitude of the magnetic field at the center of the loop is. Okay, this is carrying current I. The distance between the diametrically opposite vertices of the star is 4a. ये distance 4a है. It's a star-shaped conductor. कितने इसमें एक? It's like I don't know. The magnitude of the maximum magnetic field at the center of the loop is. Magnetic field at the center of the loop. That's what you want. Huh? Have I seen this somewhere? I don't know. Right. So like, how do I do this? It's just integration. Wait a second. ये थोड़ा सा अजीब होगा नहीं? Is yeah, I just actually have to figure it out, huh? Okay, so integration of mu naught upon 4 pi. Usually कैसे रहता है just mu naught upon 4 pi. Yeah, that's like the thing. The current और क्या था dl also r vector itself so dl vector crossed with r hat there must think like ऐसे just this thing current is going in this direction then r is in that direction so उसको cross करते हो okay you do l vector cross okay that would be in this direction got it dl vector cross r and then upon r squared right r hat चाहिए यहाँ पे okay this should be the thing just want to integrate this guy ooh that's kind of a weird thing going on so अपने को just एक part का निकालना है because basically just वो एक part रहेगा that's the thing that matters right it's gonna be long okay mu naught I upon 4 pi and then you want to integrate this guy कुछ याद आ रहा है क्या oh this thing like mu naught upon 4 pi a right sine of that guy yes that's of I sine of alpha minus sine of beta जहाँ पे ये एंगल से बीटा रहेगी of course so current is moving in this direction फिर यहाँ पे भी okay it's anti-clockwise everywhere so just the same right add करना है अपने को got it so just have to add this stuff distance साइड का दिस सेंटर पॉइंट से ये पूरे लाइन का सेम रहेगा, ये पूरे लाइन का सेम रहेगा, ये पूरे लाइन का भी सेम रहेगा. हाँ, इंटरेस्टिंग. Right, so like this distance is actually the same everywhere because ये angle कैसे बैठते हैं, right? Ah, right. Okay, so distance same रहेगा, and what is that distance though? Uh, we'll just have to figure it out. ये distance 4a है, right? And ये तुम equal triangles में इसको cut कर सकते हो by symmetry में, तुम देख सकते हो. So ये distance a रहेगा, नहीं? This is also going to be a. Yes, so that distance is just a. So mu naught I upon 4 pi a, and then sine of alpha minus sine of beta, right? Okay. So now think about it. तुम्हारे पास में angles कैसे है? This thing, ये डिस्टेंस ए है, ये है अपने को पता नहीं कितना है, राइट. ओके, ये जो पूरा रहेगा दिस डिस्टेंस इज जस्ट ए प्लस ए अपॉन 2, आई बिलीव जस्ट 3a अपॉन 2, और यहाँ पे जस्ट a अपॉन 2 है, राइट. उफ, इट्स गोना टेक फॉरएवर. ओके, वी नीड साइन एंगल्स. यहाँ पे a अपॉन 2, दैट इज 30 डिग्री, सो साइन ऑफ जस्ट लाइक व्हाट, नेगेटिव. Wait, that's not, it's like a tan is half, right? Okay, okay. What's this length? तो ये तो वहाँ पे आने ही वाला है, इन एनी केस जो भी है वो कैंसिल हो जाएगा, दिस थिंग, राइट. साइन वैल्यू दैट्स काइंड ऑफ वियर्ड. मैं श्योर यही एंगल्स थे. इट्स गॉट टू बी जस्ट 5.2 होता है ना. यस, सो what do you get? This is like 3.2, so divided with 2 1, this is 2 of course. ये distance कितना होगा? Just square root of 3 square is just what, 9 plus 4 is just 13, sort of 13 I guess, because yeah. Shit, what am I missing? I must be missing something. Otherwise it's not like the sign of that angle is like 3 upon sort of 13. Sort of 13 इसमें कहीं भी नहीं है, so something must have been wrong. It's 1 sort of 5 वगैरह आ रहा है. That doesn't actually make any sense. It's definitely something wrong. It's definitely something wrong. Otherwise, oh, the height is a, right? Yeah, but we equal a triangle. This is still the same thing. No, 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 no. This distance is not 2 actually. Okay, okay, okay. In comparison to that, it's actually like square root of 3 or something, because tan of 30 degree, right? Yes. This is actually square root of 3 over there. Oh, this is just 60 degree or 30 degree. Oh, I should have seen that, of course. Yeah, pretty obvious. So just sine of 60 is like 1 square root of 3 upon 2 minus 1 upon 2. That is just to नीचे 8 pi. Yes, that should thing. और ये कितने बार होने वाला है? हर बार, राइट? ओके, 1 2 ऐसे 3 4 5 6 7 8 9 10 11 12 बार. ओके, 12 टाइम्स ऑफ दिस गाय. सो जस्ट 6 बाहर आएगा. 6 mu naught, right? Okay, 6 times of square root 3 minus 1 over there. Awesome. Yeah, that's the thing. So that is A. Next question. Fourth answer A. Fifth is 3 vectors P vector, Q vector, R vector shown in the figure. S be any point in the vector R vector. The distance between the product P and S is P mod R vector. The general relation among vectors P, Q and S is P vector, Q vector, S vector. Okay. S be any point in the vector R vector. कौन सा R vector? मुझे कुछ दिख नहीं रहा है. Okay, Q minus P. Okay, so on this guy, S यहाँ पर है. The distance between the point P and S. अच्छा, okay. General relation among the vector P vector, Q vector and S vector is. तो ये चीज S vector है, नहीं? Right. Wait, is the S vector like the position of this thing or what? S is any point, so S vector is like, right, this thing. Okay, this is S given, of course. Okay, cool. So general relation among, yeah, I mean, no big deal. Just S vector minus P vector is equal to P times of R vector, which is just Q vector minus P vector, right? So P, Q and S. I mean, wait, that's just too easy. That doesn't actually make any sense. Huh? Yeah, that is way too easy. PQ vector and then what was it? Okay, so S vector is just what? It's just P vector times P minus 1. Oh no, 1 minus P plus PQ vector. Okay, which is A. ये तो काफी easy था. ऐसा क्यों? I don't want to be that easy. A rocket is launched normal to the surface of Earth away from the sun along the line joining the sun and the Earth. The sun is this many times heavier than the Earth and is at a distance of this thing larger than the radius of Earth. The escape velocity from Earth's gravitational field is this thing. Okay, launched normal to the surface of Earth away from sun from along a line joining the sun and the Earth. Sun is this many. Okay, capital M is equal to okay, mass of sun. S और E यूज कर रहा for sun and earth. Sun का mass S is equal to 3 times 10 power 5 earth का mass. Okay, and is a distance of this times okay larger than the radius of earth. So जो distance है that is just yeah 25 times 10 power 3 r capital R is just radius of earth. The escape velocity from the earth's gravitational field is this thing. Minimum initial velocity required for the rocket to be able to leave the sun earth system is closest to not the rotation and revolution of the earth and presence of any other planet. Wait, what revolution coordinate? Okay, that is nice. Okay, for the rocket to be able to leave the sun earth system. No big deal. Just gm m upon r, all that stuff, right? So gm upon just the potential at that point, right? Because alright, that should be the thing. Yes, and this is the distance d over there, of course. And जो क्यों दिया है this distance? Right, okay. So gm upon r plus g, or let's say ge upon r and then gs upon d, right? That's the energy or potential required, equal to half v squared. So you want the minimum velocity, of course, right? It's just v escape का square, v escape half v escape square plus ये जो चीज रहेगी just half v escape square that times of कितना बड़ा just 3 times of 10 power 5, right? Yeah, और ये क्या 10 power 3 है ना? Okay, upon 25 times 10 power 3, I guess. Yeah, so just what you get half the मर गए और you get like square root of 1 plus just 100 over there. 4, I guess, square. Yeah, square root of 13 times 4. Okay, so square root of 13 times ये चीज square root of 13 is like 3 से बड़ा, right? So between 3 and 4 or something, like 3 point something, and less than 4, 4.8. Okay, this looks good. B is the answer. B. Next question, 7th. Person measuring the depth of a well by measuring the time interval between dropping a stone and receiving the sound of the impact with the bottom of the well. The error in this measurement is delta t equal to 0.1 seconds, and the measurement, okay, delta t is equal to 10 power -2. Measurement of the depth of the well is found to be L is equal to 20 meters. Okay, L equal to 20 meters. Or can I take the acceleration of gravity is equal to 10, and the velocity of sound is equal to 300. Fractional error in the measurement of delta L upon L is closest to. Okay, depth of L by measuring the time interval between the dropping a stone and receiving the sound of impact. Right, so sound कुछ में ऊपर बस जाना है. That's the thing. Yeah. The measure this thing. Okay, take velocity of sound. Okay, cool. Acceleration of the gravity g. Velocity of sound. बस इतना ही है ना. Wait, acceleration of the gravity. This measurement of time is this thing. Does it matter what g is though? Because yeah, the time interval, right? Okay. हाँ. Wait, तो अपन ने जो टाइम कैलकुलेट किया वो क्या कौन सा टाइम है ये? ओह ओके, अपन उसको खुद को कैसे समझेगा कि वो कहाँ पे गिरा हुआ है? उसको मेजर करना है वो. राइट, ओके ओके. वेट, बट ही कैन सी ऑफ कोर्स. तो फिर ये कैसे तो दोनों साथ ठीक है. मैं इसको ना अज्यूम कि वो वैसे कर रहा है. सो व्हाट, लाइक सी अपॉन टी. सम वियर्ड थिंग गोइंग ऑन. L upon C is equal to our time measured, right? Wait a second. Oh, I know तुम क्या कर रहे हो. Right. So like L upon तुम्हारा जो time measured is like not that, it's this thing. So L upon C plus half GT. Okay, that's not the thing. Sorry. L equal to half, which is like square root of 2L upon G, right? That is equal to the total time required, right? Exactly. So let's go derivate करो. This is what you get. Delta L upon C plus इसका derivative just what? दिमाग खराब हो रहा है कर करके. Square root of 2 upon G common ले लिया. This is what you want. नीचे से square root of L. Delta L over there. Let's go to delta T. Awesome. Natural log अपन डायरेक्टली ले नहीं सकते for some reason. Yeah, वो it's gonna be so complicated, right? I think actually calculate करना पड़ेगा. Whatever. Delta L and then 1 upon C plus square root of the 1 upon square root of 2GL is equal to delta T, right? Exactly. Let's do it. So delta L times C is 1 upon 300 plus 1 upon square root of 2GL, which is 20 times L kitna tha apna? Just 40, okay, like 400. Just 1 upon 20 over there. Yes, that makes sense. This is equal to 10 power into ये छोटी सी वैल्यू क्यों ले रहा है इसमें? C is just that. Oh. Yeah, I believe this is correct. This should be correct. Yes, that's right. This is a thing, of course. So just you can find it to just 1 upon 100. Well, like whatever 100. What do you get? Delta L times 1 upon 3 plus 5 equal to 10 power equal to 1 basically. So ठीक है ना? Delta L is equal to 3 upon 16. Just 3 upon 16. So what do you want? Delta L upon L, right? And then this is 20. So divide by that. Yeah. And you want in percentage, especially this times of 5, which means key. God, what is this thing? Okay, just 15 upon 16 percentage, which is point something. So definitely not this. Okay, closest to B, I think. Seventh answer B. Next, eighth. Eighth is this section contains 7 questions. Blah blah. Okay. Uniform magnetic field B exists in this region between 0 and 3R upon 2. Region 2 is in the figure pointing normally into the plane of paper. What? Region 2 normally. Wait, what? 3R upon 2. X कहाँ पर है? So ये 0 है and this thing is 3R upon 2. Region 2 in the figure. Okay. इस region में uniform magnetic field है pointing normally into the plane of paper. Enters region 2 from region 1. 1 से 2 पे जा रहा है. At point P1, y equal to negative R, which the following options are correct. So it's going from 1 to 2, y equal to negative R. अच्छा, okay, ये अपना charge particle है. So the following is correct. For B, blah blah blah, the particle will enter region 1. ऐसे चाहिए अपने को. ठीक है ना? Let's do it. So just that it re-enters region 1, it should actually go like this. तो यहाँ पे ये radius basically निकाल लो. What is our radius? Radius is just wait. What is the radius? Oh, we actually want radius. mv square upon r. Yeah, I mean it enters at some velocity. कुछ दिया है क्या अपने को? कुछ भी नहीं दिया यार. अच्छा, momentum दिया अपने को. Awesome. So it's like p square upon 2m. Actually, we will do that later. mv square upon r is equal to क्या था से? हाँ, okay, q b v. That's the force. So v गया. Just get p upon r is equal to qb. Right. So for b bigger than this, like b is equal to, actually like r is what? R is p upon 2q. Sorry, p upon qb. And this thing should maybe 2/3 कैसे आ रहा है यार? Will re-enter region 1. It's just going like this, so it should just Oh, अच्छा, वो r जो है वो अलग वाला r है. Okay, sorry. So this thing, ये radius, it should be less than your 3r upon 2 thing. So your r should be bigger than 2/3 of. Okay, got it. Like b is bigger than 2p upon 3qr. That makes sense. So A is correct. और क्या है? For b equal to this thing, the particle will enter the region 3 through a point p2 on the x-axis. Through the point p2 on the x-axis. कौन सा point? अच्छा. So for this certain b, right? 3 upon 2 r क्यों लिया इन लोगों ने particularly? I don't know. Will enter. Okay, so just वो जो circle it just goes through these 2 points, right? कौन से 2 points? Wait a second. इसका तो radius चाहिए नहीं? Okay, that's like the horizontal over there. First figure out कि ये radius क्या है इस वजह से, नहीं? Yeah. So what's the radius? We'll see. Right, the radius is actually this constant thing, isn't it? तो जो r है is just pq upon r. What is the thing? मर रहा हूँ मैं. R is equal to p upon qb. Okay. So b is this thing, which means कि right. What's r? R will just be p upon q times 1 upon b, which happens to be just 13 upon 8 times qr upon p. ये तो मरा. Or it's like 13r upon 8. 13r upon 8. So this is at 13r upon 8. अच्छा. Okay, that's our radius, right? 13r upon 8. Okay. This thing is 3r upon 2 though. Oh, the center, of course. That is at this point you're saying. Isn't that right? Okay, so ये कौन सा point है? It's just 0, negative r. अपना जो center है, it's based at 0, 13 r upon 0. Just 7 shit like 5 upon 8 r. And ये जो distance है, where did that go? Yeah, it's just कहाँ पे मर गया ये distance? It's just x coordinate पे 3r upon 2. 3r upon 2, 0. Right, okay, let's just figure out the thing. Forever 5 upon 8 r square is equal to the distance between 5 upon 8 plus 1. That does not make sense, right? No, it doesn't. Wait, I'm missing something. At least I get that point. Now, for it to be passing through that, what should happen is key, right? Like distance, which is just x square plus इसके y coordinate का difference का square, which is तो हमें y coordinate होगा y minus r squared, small r squared basically, right? मैं पागल हो रहा हूँ यार. Okay, that's capital R, sorry. So small r minus capital R का square. This distance plus ये चीज 3r upon 2 का square. Why is this happening to me? Okay, ये distance should be equal to r squared, right? That's when this will happen. Oh, ये small r squared चाहिए यहाँ पे. Yeah. So you just figure out the r in that way, like r square minus 2r plus r squared plus 3r squared upon 4 equal to small r. So r square मर गया. What do you get? ये just 2r is equal to 1 plus 9 upon 4. Which is like what, 13 upon 4r. So okay, r should be 13 upon 8, which is what we had. तो ये क्यों गलत हुआ अपना? I'm just giving up now. ये सही नहीं हो रहा है यार. It should be 13 upon 8, right? Subtract करो, what do you get? Just get 5 upon 8. 5 upon 8 is over there, right? ये 3r upon 2 है. So what do you get? Like 5 upon 8 का square. Oh, the radius is like 13 upon 8. Okay, so it is actually correct. A is correct. 8 का A correct है. Oh, sorry. B correct है. Right. That's what I should have said. So B is in fact right. Okay, when the particle re-enters from region 1 through the longest possible path in region 2. In region 2 and longest possible path. Okay. Magnitude of the change in its linear momentum become momentum between point P1 and the farthest point from the y-axis is p upon square root of 2. What? Kya re-enters region 1 through the longest possible path in region 2. Okay. Right, which is when this is like just touching at that point, of course, so radius should be less. Yeah, okay. Right, the magnitude of a change in linear momentum between points P1 and uh, the farthest point from y-axis, which is just that point. Okay, that is equal to p upon square. No, that's. Are you serious? It is square root 2p, right? That's pretty obvious. For a fixed b, particles of same charge q and same velocity v, the distance between the point p1. Right, multiple choice, है ना? Okay. Fixed p particle of same charge q and same velocity v. Distance between the point p1 and the point of re-entry into the region 1 is inversely proportional to the mass of the particle. Same velocity v. For a fixed charge, what? For a fixed b particle of same charge q, the particle का charge में same रखा है, same velocity. The distance between the point p1 and the point of re-entry to region 1 is inversely proportional to the mass of the particle. Okay, ये re-entry पे जो point रहेगा. Distance between this, that is 2r यार. Inversely proportional to the mass of the particle. I just like saying that r is proportional to 1 upon m. Is that a thing? Yes, wait, no, it's proportional to m itself. So, wait, so p same है, momentum. Okay, then it's correct. It is just that. Yes, 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 yes. Wait, nahin. Something's going wrong, is it? P upon r equal to qb, right? So r equal to p upon qb. It's actually constant. और हमारा p तुम same रख रहे हो. Same velocity. Right. It's proportional to mass, not inverse proportional. Next question. Instantaneous voltages at 3 terminals marked. Okay, given by this thing, ideal voltmeter is configured to read RMS value of the potential difference between the terminals. Huh? Okay. Ideal voltmeter is configured to read RMS value of the potential difference between the terminals. It is connected between points X and Y, and then between Y and Z. The readings of the voltmeter will be. Oh, okay, okay. So RMS value, right? Okay, got it. Yeah, so like, let's do it. Square root of the average of the square. So, right. What's the phase difference का difference है, right? Okay, it's like, of course, of course, of course. So हमारा difference रहेगा, it's like दो phases के बीच का mag. Okay, got it, got it, got it. पहले का square, दूसरा square, फिर minus 2 times of the phase. Yeah, that cancels. So जो दूसरा part है वो cancel हो जाएगा. Yes, yes, it is. The RMS is just that, right? Of course. In that length is actually constant, isn't it? Whatever, right? Oh God. Yeah, it just like v naught बाहर आ जाएगा. It's basically यहाँ पे 1/2 है, फिर plus 1/2 है. It turns out it's the same everywhere because yeah, well, is that the case? जो अपना square है ना, difference of like 2v, तो वो एक square होगा, यहाँ पे एक square होगा, and then you want 2v naught square sine of each sine of each. Okay, so that you can decompose as cosine difference minus cosine of sum, and that cancels out anyway. Oh नहीं, वो cosine का वो that is not actually cancel out. Got it. Right, that does not cancel out. Instead वो वहीं पे रह जाएगा नहीं. Okay, तुम्हारा जो phasor है, like what am I doing exactly? I don't know. It's just phasors. Okay, okay. तुम्हारा जो phasor का magnitude है, what's that? V naught square root of 1 plus 1 plus 2 cosine phi, which happens to be, okay, 2v naught sine of phi upon 2 or whatever, right? And फिर अब इसमें 1 upon square root डाल दो because yeah, square root 2v naught sine of phi upon 2. That's the RMS value. The readings of the voltmeters will be so, and phi upon 2, इसमें phi कितना है? 2 pi plus का half. Okay, pi upon 3 का sine is just what? So 3 upon 2, so 3 upon 3, which is like what? So 3 upon, so of 3 upon 2 times v naught. So A is correct answer. और क्या है? So yz, once again phase difference is 2 pi upon 3, same stuff. Okay, xy अभी तो किया यार. No, element of the choice of the two terminals. No, that's not the thing because it's major difference. Right, okay. xz जहाँ पर हैगा, yes, it's just 2 pi upon 3 और उसका sign. Oh, that also turns out to be, yeah, that's pretty awesome. It is. So yeah, it's just independent of the choice of two terminals. So D. Huh. Very interesting. Next question. A point charge Q is placed just outside an imaginary hemispherical surface of radius R as shown in the figure. So the following statements is or are correct. Plus Q placed just outside an imaginary hemispherical surface of radius R. Okay, it's a spherical surface. ये charge है. So the following statements are correct. Elastic flux passing through the curved surface of the hemisphere is this thing. Hemisphere. Oh, okay, ये भी इसमें consideration में. Okay, got it. Electric flux passing through the curved surface. So, oh god, oh, that's not going to be easy. Through this surface, you are saying, ah, it's this thing, negative q upon 2 epsilon naught, and then you got this thing, right? Oh, just figure out कि इससे क्या flux pass हो रहा होगा, right? Through this thing, of course. Yes. अब मैं उसको कैसे करूँगा? Like a cylinder or something. That's just stupid. What's wrong? KQ solid angle रहता है, right? Yes. I mean that's why. So इसका जो solid angle है, what's that? I mean it's just at R. So ये angle कितना है? This is just that's just 45 degrees, isn't it? Because yes. So half angle is 45 degrees. Our solid angle is just 2 pi 1 minus cosine phi. Sorry, 1 minus cosine theta. In this case, cosine theta is just 1. Oh yeah, just 1 minus 1 upon square root of 2, right? Because yes, I believe that is right. Wait a second. Let's have a it's like Mojo half and is like that becomes 5. Yes, it's good. It's good. No big deal. This is the thing. So sigma is just that. तो ये क्या है? Q upon 2 epsilon naught times 1 minus 1 upon square root of 2. Which is, yeah, okay, that's the thing, of course. Wait, that's the flux passing through this guy, no, negative of that guy. So that's right. This 10th का A correct है. और क्या है? But flux to the curved and the flat surface. I mean, okay, wait a second. Oh, it's because it's negative. Got it. The total flux to the curved and flat surface is this. I mean, it's actually supposed to be 0 though, because the component of the electric field normal to the flat surface is constant over the surface. Electric field over the कौन सी surface? अरे, electric field normal to the flat surface. अच्छा, normal to the flat surface. No, it's not constant. It's 1 upon r squared. So how the hell is that constant? यहाँ पे, yeah, okay, that's not constant. Circumference of the flat surface is an equipotential. Yes, that is circumference. Circumference. Wait, what? What do you mean by circumference of a flat? Oh, flat surface. Sorry. Is an equipotential what? Line path? I guess you could say so. So ठीक है ना? D looks correct. Yes, D looks correct. और क्या है? This is wrong. This is wrong. So A and D. Next question. 11th. Two current monochromatic points with S1, S2 of wavelength lambda equal to this thing. Lambda is what? 6 times 10 power negative 7. Okay. Are placed symmetrically on either side of the center of circle as shown. The sources are separated by distance d equal to. So distance is equal to 18 times 10 power negative 4. Okay. This arrangement produces a interference fringes visible as alternate bright. Okay. The angular separation between two consecutive bright spots is delta theta. So the following options is not correct. Okay, dark spot will be formed at the point P2. Wait, what? Consecutive bright spots is delta theta. Okay. So a dark spot will be formed at point P2. Point P2. No, we don't know for sure. Okay, at P2. I mean, it depends कि D कितना है यार. At P2, the order of the fringe will be maximum. Look, मुझे पता नहीं P2 में fringe होने वाली है कि नहीं होने वाली है, right? How do you even say this? Like d sine theta. Okay, yeah. So d delta theta is equal to lambda, right? That's what we do. जो भी है, total number of fringes produced between P1 and P2 in the first quadrant is close to 3,000. Wait, तो लैम्बडा दिया है ना? हाँ, तो लैम्बडा दिया है, so then actually you can do this thing like d sin theta कितना है, right? Yeah, for example when theta is equal to 0, it is phase difference is like gone, part difference, right? इस केस में क्या होगा, थीटा इज जस्ट गोइंग लाइक फुल 90 डिग्री, so just 1d. And is that a multiple of this thing? Yes, it is exactly a multiple of that thing, which means, right, okay, it's some kind of n lambda thing, right? Yes. अच्छा, n की वैल्यू क्या होगी, n is equal to 3 times 10 power 3 is like 3000, तो ये 3000 फ्रिंज रहेगी. yes, between p1 and p2, yeah, it's close to 3000, so c is correct. And dark spot will be formed at p2. अब डिपेंड्स कि तुमने ये कितनी प्रेसिजन पे दिया हुआ है, बट आई गेस यस. वेट, नहीं, ब्राइट स्पॉट ना, बिकॉज 3000 इवन नंबर, फर्क नहीं होता, इट्स एन इंटीजर, दैट्स व्हाट हैपेंस. ऑर्डर ऑफ फ्रिंज विल बी मैक्सिमम, यू कुड से सो, आई गेस, आई डोंट नो. इट्स अ स्फीयर, राइट? तो एक फ्रिंज अपन बोल रहे हैं एक्चुअल में एक फुल सर्कल रहेगा, नहीं? या राइट, सो देन इट्स मैक्सिमम, यस, बिकॉज yes, like 0 से तुम start करो till that. So yeah, B looks correct. C looks correct. The angular separation between two consecutive bright spots decreases as we move from P1 to P2 along the first quadrant. Okay, कैसा रहता है? Just d sin theta is equal to n lambda. So अगर इसको differentiate कर like, yeah, मतलब approximately इसको differentiate कर रहे हैं. You could think of it like that. So lambda is equal to d cosine theta and then delta theta, right? Exactly. So delta theta is just lambda upon d cosine theta, which means कि yes, so as we move, यहाँ पे मैक्सिमम था अपना डेल्टा थीटा, शिट मिनिमम था. अब as it moves, it will become bigger and bigger and bigger, right? Exactly. Angular separation between cos and right, this decreases. I don't think that's what's happening though. Cosine theta, right? Lambda upon d cosine theta. Uh, d is the distance, of course, or cosine theta is what it's decreasing, so this should completely increase, right? Yeah, it should increase, not decrease. So this is it. Next question. Length अपन क्या कर रहे थे? B and C. 12. 12 is a source of constant voltage V connected to the resistance R and two ideal inductors L1 and L2 through a switch S as shown in the figure. There is no mutual inductance between the two inductors. The switch S is initially open at equal to 0, switch is closed, current begins to flow. Which of the following options are correct? वोल्टेज भी अप्लाई किया है, ये सोर्स, ओके. स्विच जो है, there's no mutual inductance between the two inductors. When switch S is initially open at equal to 0, the switch is closed and the current begins to flow. So following is not correct. हाँ ठीक है, तो अब ये स्टार्ट हो रहा है फ्लो होना, which means, oh god, अच्छा ये तो अपोज कर देगी ना इसको. yes, so after a long time, okay, good, after a long time ये वायर से just, yeah, the current through L1 will be this. हाँ, wait, how do we know कि वो करंट क्या होने वाला है? Oh, we will need the differential equations, nahi? Yeah. So like L1 di1 upon dt is equal to V, right? Or like L di upon T. So through that current, okay, so like you want L डाल दो, तो current is just of the form V upon L times T through this inductor, nahi? Exactly. Which means at some time, yeah, that actually does make sense. It's a negative, okay, that would just this thing, but whatever. Famous IR लगता है, but जो भी है. Yes, this is the thing. So it's just, वो जो integral रहेगा, it's like 1 upon L is proportional to 1 upon L, right? That's what the current is proportional to. Okay, so current through L1 will be what? It's just 1 upon L1 upon 1 upon L1 plus 1 upon L2, which is, yes, it's just L2 upon L1 plus L2, right? And after long term, L2 will be this thing. Yes, of course. So A is correct, B is correct. और क्या है? Ratio of current through L1 and L2 is fixed at times. T begins. Yes, that's right. So C is correct. उसमें इंटीग्रल दोनों के लिए सेम है, and then just 1 upon L सामने आता है. At t equal to 0, the current through resistance R is V upon R. Current is 0 actually. Okay, next. Rigid uniform bar AB of length L is slipping from its vertical position on a frictionless floor as shown. Some instant of time, the angle between the bar with the vertical theta find which of the following statements does not about its motion is not correct. Midpoint of the bar will fall vertically downward. Yeah, that's correct. So तीन का A. ये तो मेंस टाइप हो गया कुछ तो भी. Okay, the trajectory of the point A is a parabola. इसकी trajectory parabola है. Okay, it's just falling down in. Oh, okay. अपने गच्छ में इसकी trajectory निकालनी पड़ेगी. God. Huh, whatever. Wait, we only want the trajectory. We don't actually want the timing, right? Or do we? Oh, right. We don't actually worry about timing at all, huh? बस इसकी trajectory चाहिए. Oh, that's actually very easy. Yeah. तो ये कैसा है? This is just L upon 2 over here. यहाँ पे कुछ भी angle होगा. We don't care what that angle is. So ये तुमने थीटा लिया ना? This is actually theta. Whatever. Okay, the center of mass should just be there. Awesome. Let's call this as the origin. Okay. तो इसका x कोऑर्डिनेट क्या रहेगा? नेगेटिव l कोसाइन थीटा, नेगेटिव r कोसाइन थीटा, l अपॉन को r बोल रहा हूँ, और y कोऑर्डिनेट विल जस्ट बी, oh it's just that, right? Exactly. 2r sin theta. Yeah, just an ellipse. It's an ellipse, not a parabola. Exactly, it's an ellipse. Yes. Okay, the midpoint of the bar will fall vertically downward. Huh? By the way, negative में क्यों डाला? Whatever, just reflected ellipse, whatever. Okay, the midpoint of the bar will fall vertically downward. Okay, that's right. The trajectory of what? Okay, it's not a parabola, it's a ellipse. This is talk about the point in contact with the floor is proportional to sine theta. Torque about the point in contact with the floor, this point. Acha, about that you just want the torque, right? Torque about center of mass and torque of center of mass. Center of mass पे क्या चीज़ है? Like about center of mass में normal force लग रहा है, but then we don't actually want that because yeah, it doesn't actually matter, right? वो जो normal है actually it doesn't cause any torques. तो सिर्फ जो बाकी forces बचे हैं, which was what? Gravity, right? Because of this, that. So like integration of that's the thing. Torque is just acting about this point, right? Yeah. So it's proportional to what? Sine theta. Sine theta is just ye cheese exactly. L upon 2 sine theta is just this thing, which means yes, it is. Okay, so C is correct. Theta with the vertical distance of its midpoint from the initial position is proportional to 1 minus cosine theta. R makes angle theta with the vertical distance from its midpoint from the initial position. Huh? Oh, of its midpoint from the initial position is proportional to friction नहीं है इसमें? हाँ, good. So from its midpoint from the initial position proportional to 1 minus cosine theta. Ah, right. Okay, that. Okay. You should have told me. I just y coordinate. Y coordinate कितना है तुम्हारा? Yeah. Okay. Yes. So इसमें sin नहीं, इसमें cosine रहेगा. Yes, like r cosine theta, and then it will r itself. So yes, it's just minus cosine theta. That makes sense. So D is correct. But ये तो मुझे क्यों पूछ रहे हो? इसे तो सबको पता है यार. Wheel of radius r, mass m, placed at bottom of a fixed step of radius of height r as shown in the figure. A constant force is continuously applied at the surface of the wheel so that it just climbs up the step without slipping. Consider the torque tau about the axis normal to the plane of the vapor passing through the point Q. Passing through what? A wheel of radius r, mass m, placed at the bottom of a fixed step of height r. Fixed step of height. Okay, yes, type it. Constant force continuously applied on the surface of the wheel that it just climbs the step without slipping. ये व्हील है, सरफेस पे तुम अप्लाई कर रहे हो कैसे? अच्छा, बट कौन से पॉइंट पे? I don't know. Consider torque tau about an axis normal to the plane of the paper passing through the point Q. Okay, which of the following options are correct? But कहाँ पे तुम अप्लाई कर रहे हो? You should have told me, right? अच्छा, if the force is applied at point P tangentially, then our tau decreases not continuously as the wheel climbs. And what you're seeing, it's a कांस्टेंट फोर्स ओके हाउसिंग फ्रिक्शन काफी बड़ा है just climb the step up without slipping think about it you do need to put in energy for that and which is such that it's like just flattening gravity right exactly okay what about the friction though yeah assume it's like stuck over there if the force is applied at p tangentially then r decreases continuously as the wheel climbs what is r sorry tau decreases continuously as the wheel climbs no about q चाहिए ना अपने को so it doesn't change actually because it's constant force so yeah I'm saying constant force that's what you're saying right and there's like gravity and whatnot the force is applied normal to circumference at point x then tau is constant पर ये टाउ किसका है ये टोटल फोर्स का है कि क्या दिस इज जस्ट दिस फोर्स और व्हाट उसका ग्रेविटी और समथिंग okay think that component of this guy and that changes of course that actually decreases so actually increase होना चाहिए ना yeah the torque should increase in fact so that would be wrong anyway okay if the force is applied normal to the circumference at point x and tau is constant normal to the circumference at a point x okay then tau is constant what how is that tau constant hai yes but then point p then it's wait normal to the circumference oh oh like that okay so it's in this direction right mm-hmm. Yeah but it still has a component so that's not too problematic right oh it is problematic actually because that right like tau is just zero in fact not constant it's like zero at p but at this point it's not because it's thoda sa radial vector hai thoda sa tangential vector hai. Yes so this is constant at zero the force is applied tangentially at point s then tau is not equal to zero but the wheel never climbs up right tangentially at point s then tau is not equal to zero yes it's not equal to zero but the wheel never climbs the step ऐसा क्यों भाला what why does that actually happen I don't know they should probably climb up anyway right yeah well I'm missing something it's in that direction right so this it is battling gravity anyway so it should climb up unless there's something I'm missing no it should climb up it doesn't yeah it should climb up right initially to point s then no d is just wrong so c is correct and d is correct I think इसका बी एंड सी ये कैसे क्वेश्चन है यार पढ़ने में आधा टाइम चला जाता है इनका ओके 2 paragraphs yeah okay what in the circuit shown the switch s is closer t equal to 0 and the capacitor is fully charged to voltage v naught I charging continuous for time t much bigger than rc okay in this process some dissipation e naught occurs across the resistance r it is fully charged to a voltage v naught fully charged to a voltage v naught okay it's that kind of right it's like damped of course because my energy decreases whatever okay in the process some dissipation occurs across the resistance r the amount of energy finally stored in the fully charged capacitor is ec okay in a different process the voltage is first set to v naught upon 3 and maintained for a charging time t much bigger than rc oh god what is this thing so ये process 1 और process 2 के बारे में दिया process 3 का कुछ नहीं दिया right okay voltage is first set to v naught upon 3 and maintained for a charging time much bigger than RC. Then the voltage is raised to 2 V naught, okay, without discharging the capacitor, and again maintained for a time. Okay, the process is repeated one more time by raising the voltage to V naught, and the capacitor is charged to the same voltage. Okay, three-step process. Right. The processes are debated. Okay. In process one, the energy stored in the capacitor is EC, and the heat is spread across the resistance D is related by. Okay. Energy stored about capacitor is the same in both cases, it's half CV squared. Voltage same, eh? Yeah. Okay. Um, and the heat is separated about the resistance E naught. Now the charge flow हुआ is CV, by that times of V is CV square. So CV square work करना पड़ा इस बैटरी को, and then this gain only half CV square, so बचा हुआ half CV square got dissipated. So that just means like EC equal to ED. So 15 का A और क्या है? Total energy dissipated across the resistance ED is, okay, so the charge तो still वो same ही निकालना पड़ा. I mean, yeah, it doesn't matter कि तुम कैसे करते हो, नहीं? It doesn't actually. It really doesn't. वो डिसिपेशन तुम्हारा स्टिल होने वाला. तुम्हें अगर इसको चार्ज में यहाँ से यहाँ पे लाना है, like, yeah, you just have to dissipate anyway. Work done by the battery is still the same everywhere. Wait. No, okay. इसे तुम्हारा वोल्टेज चेंज कर रहे हो ना तुम. राइट, तुम्हारा चार्ज सेम फ्लो हो रहा है, बट देन वोल्टेज इज चेंजिंग थ्रू आउट. Okay, got it. So you want dissipated across resistors ED. Okay, got it. So minus 1 upon 2 CV square, और फिर क्या? The charge that flew is पहले तो CV upon, तो मैंने पहले voltage upon 3 किया था. Okay, just CV upon 3 and that with V not upon 3. So CV square common ले लो. What you get is like 1 upon 3 का square 1 upon 9. फिर उसके बाद में किया once again 1/3 CV voltage flow हुआ, but at 2/3, so actually 2 upon 9. And then फिर finally जो 1/3 voltage गया, that was at 1, which is like 3 upon 9 if you will. Right, that should do it, which is like how much? 3 upon 9 का double. 2 upon 3. 2 upon 3 minus 1 upon 2, which is just 1 upon 6. 1 upon 6 CV naught squared, right? Yeah. So C looks correct. 16th ka. Awesome. Next. Paragraph 1 was a circular ring of mass and radius r near the top of one's finger as shown in the figure. Notice the finger never loses contact with the inner rim of the ring. The finger traces out the surface of a cone dotted by the what? Surface of a cone. Okay. The line. The radius of the part traced out by the point where the ring and the finger is in contact is r. So ये जो point है, that's like, okay, that's r throughout. That's kind of weird, isn't it? It's a cone. We actually don't care about the cone really, do we? No, we don't. Right. The rotating ring rolls without slipping on the outside of the smaller circle described by the point P, where the ring and the finger is in contact, figure 2. The question of friction between the ring and the finger is mu. So ये जो point of contact is like as rolling about it, as r, right? And then the central point कहीं तो भी तो होगा, we don't know. And this is like, okay, got it. Question of friction between the ring and the finger is this thing, and the acceleration due to, and wait, it rolls without slipping. Oh, okay, on the outside of this. Okay, got it. So the point of contact by itself is moving, and उसके about ये roll कर रहा है. Oh God, what is this? This is some kind of monstrosity. Okay, shit. Wait, अगर ये roll कर रहा है, you are in a rotating reference frame in that case. Just have to think about this center point, right? Exactly. Okay, this will be rotating as well. Okay, this question of friction between this mu and acceleration. What? Okay, इसमें friction भी रहने वाला है. Then value of omega naught below the ring will drop down. This is kind of complicated, isn't it? Okay, well, think about it. ये हमारा सा R है, it's just rolling about this thing. There's friction happening. अब देखो पहले से kinetic एक बार check करना पड़ेगा. Total kinetic energy of the ring is Yeah, first of all, you need the velocity in omega about its own center of mass. So how do you do that? And कुछ दिया है क्या आपने को values? ओमेगा नॉट क्या है ऐसे? हाँ, okay. Finger rotates with angular velocity omega naught. Okay, so like ये जो point of contact it just moves with omega naught, right? Exactly. Hmm. Wait, the point of contact moves with omega naught. This is kind of weird thing, isn't it? Yeah, well, think. The whole guy is just rotating up there. Okay. जहाँ भी पॉइंट ऑफ कांटेक्ट रहेगा, आई मीन इट्स जस्ट अबाउट दिस कोन, तो जहाँ भी पॉइंट ऑफ कांटेक्ट रहेगा दैट एक्चुअली डिटरमाइंस कि ये सेंटर कहाँ पे होना चाहिए दैट केस, राइट? सो दिस बाय इटसेल्फ लाइक it's a it's actually a rigid body in that case, right? Wait, so if I'm gonna wheel something, wait. Yeah, the point of contact, wherever that is, there also changes by the way. Huh. The finger rotates with angular velocity omega naught. So point of contact. So ठीक है, मुझे वो समझ रहा है, but then what I do not understand is कि how do I even model this thing? Uh, it's not just that. Actually, the whole thing is living as well, right? So there's some thing because ये rotate हो रहा है, and then there's also the thing कि ये जो thing है, actually ये इसके about rotate हो रही है, right? Exactly. So इसका position vector about this guy that is changing. This is just too much for me to handle right now, but still think on it. In the rotating reference frame जहाँ पे तुम्हारा right in your fingers reference frame, right? Okay. Yeah. Okay. तो अकॉर्डिंग टू दैट हमारे पास में क्या हो रहा है, इट्स जस्ट ये जो पॉइंट है फ्रॉम दिस डिस्टेंस, राइट? इट्स जस्ट रोटेटिंग अबाउट दैट. ओके. शिट, आई डोंट अंडरस्टैंड हो क्या रहा है यहाँ पे. इट्स लाइक गोइंग इन दिस डायरेक्शन, व्हाट नाउ? आई थिंक what is this guy's omega not about this? That position changes, isn't it? Right. Yeah, ऐसा change हो रहा है, ऐसा change. Yeah, okay, it changes like this thing. So if I just figure out कि ये कैसे move हो रहा है, then that's like saying, oh, that will actually give me the thing, right? That will tell me कि उसका omega कितना है. Exactly. It should be stationary with this guy. Hmm. Of course. So that must be stationary. Let's just say that it's rotating by omega over here. Okay. So the velocity at this point that should be zero because yeah. I mean that's at contact points. That should be zero, right? So this is like what omega r small r is equal to zero. But omega capital R is this guy's velocity in the rotating reference frame. Okay. We're assuming कि ये जैसे rotate कर रहा है, also rotating in the same direction. Suppose ये anti-clockwise move हो रहा होगा. It's also rotating anti-clockwise by omega. Or you can just say this thing, omega minus omega naught. Yeah, that explains it. About this central point still rotating on omega, right? Exactly. That should have been. Yeah, मतलब उसके अकॉर्डिंग वो रुका हुआ है. Yes. It's kind of weird. ठीक है, वो जो एंगुलर चेंज हो रहा है. Right, so omega minus omega naught, that's this angular velocity. And as of r, that has to be equal to zero. I mean, yeah, actually. Wait, नहीं. Who told you it's supposed to be zero? Wait, but that is actually. Now it's not making sense anymore. ये ऐसा नहीं हो सकता ना कि it's just fixed over there. That's not possible. That's definitely not happening as well. It is rolling about our finger, तो it must be rolling, right? मतलब yes, at different points touch करता है. This is not making sense. So what's our conditions is that this actually uh, so ऐसे pure rolling condition क्या होगी? We don't know, fortunately. I have to make that guy. Think clear कि उसका distance from this point is constant throughout, so we can definitely write like this कि वो ऐसा move हो रहा होगा. Okay, awesome. And that's rotating like that. We can also do that thing. Or फिर what you have is कि this point it moves like this, doesn't it? Exactly. अगर मैं कुछ भी इसके angular velocity डालता हूँ relative, then it's going to move, right? With respect to this, it's actually going to move. That is not what I want. और इसका distance अपन change कर नहीं रहा है. So what does it actually mean? Uh, yeah, अपन इसका अपन distance change नहीं कर रहे हैं. That only means one thing, that omega should be equal to omega naught. मतलब it is in fact omega. Yeah, it is actually moving with omega naught. So it's as if वो एक single rigid body हो. Okay, okay, okay. Then okay, it's doable. This inertia about this point, right? Exact. Oh, ये पहला अच्छा क्वेश्चन मिला मुझे. Yes. So what you have is mr squared plus m times of r minus r का square. That's our inertia about this point. That's of omega naught. I know it sounds counterintuitive कि actual में एक single rigid body से अपन consider कर सकते हैं, but that is the thing. That just is the thing, right? Point of contact is moving. और अपनी फिंगर अपने ओरिएंटेशन को चेंज नहीं कर रही है. सो हाँ, इंटरेस्टिंग. हाँ मतलब इसके अंदर एक और सर्कल इमेजिन करो एंड ओ यस, दैट एक्सप्लेन्स इट. दैट एक्सप्लेन्स अ लॉट. ऑफ कोर्स. सो व्हेन वी सेड द फिंगर इज रोटेटिंग, तो वो जहाँ पे टच कर, ओके, दैट पॉइंट रोटेट्स एज वेल with the angular velocity that finger is rotating. Yes, 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 yes. So if the finger is rolling like ऐसा जा रहा है and this is also going with the same. हाँ, फिंगर रोल कर रही है अपनी एक्चुअल, और आई शुड से कि ये जो अंदर की रिंग है दैट इज रोलिंग अबाउट आवर फिंगर. यू कैन काइंड ऑफ थिंक ऑफ इट लाइक दैट कि बस फिंगर के कॉन्टैक्ट पॉइंट्स अलग अलग रहेंगे, नहीं? यस. सो विद रिस्पेक्ट टू द रिंग अपनी फिंगर रोल कर रही है. एग्जैक्टली. At different points you are actually going to touch this. It's kind of weird, isn't it? Yeah. It's not just revolving, actually rotating at the same time. That explains it. Look, तुम्हारी जो finger, it's not only revolving about this center, but it's also rotating about itself. उस वजह से वो फिंगर की ओरिएंटेशन सेम रहने वाली है, राइट? ये इतना इजी था यार. एंड दैट मींस की कांटेक्ट पॉइंट इज आल्सो रोटेटिंग. ओके, दैट एक्सप्लेन्स इट. सो दिस इज एक्चुअली करेक्ट. हाफ आई ओमेगा स्क्वायर ओमेगा नॉट का स्क्वायर, राइट? व्हिच इज व्हाट. ये अच्छा क्वेश्चन था. काफी दिनों बाद मुझे अच्छा क्वेश्चन था, राइट? सो okay, that's not there for some reason. What are actually the ring? He's talking about this guy. That's what he said though. And that's not there for some reason. कुछ दिया है क्या स्मॉल आर और कैपिटल आर के बारे में? कुछ भी नहीं दिया है. So now what? That's just capital R squared over there. So that's the inertia about this guy, and then about center of mass is this thing. Okay, ये थोड़ा सा कॉन्ट्रडिक्टरी लग रहा है मुझे. This should not be the case. This should just be not the case. She plus and everything and It's not the case, of course. Yeah, unexpected. So r squared plus अभी तो मेरा सॉल्व बता, ये वापस कॉम्प्लिकेशन इसमें हो गया है. It's definitely not that. I know it. It's not. It's rotating about this point, not okay. I don't know. फिर अब ये क्यों incorrect है? This should really just be half m capital R square plus capital R minus small r squared, that is of omega naught squared, because that's what's happening. It's rotating about this point. Yes. Or the center of mass is rotating about that point. Who said कि ये actually खुद rotate नहीं हो रहा है about? Yeah, I mean that could also be happening in fact. Of course. Yes. Okay, and the finger is rotating by omega naught. Okay. तो ये खुद भी rotate हो रहा है, so that actually happens. Yes. Finger की orientation नहीं change हो रही है. That's what we have. This is kind of complicated. That's actually moving around that. तो तुम बोल रहे हो कि इसके about actually move करना चाहता है. That is interesting. So इसके about ही rotate हो रहा है. Would have never expected that. ठीक है. So actually वहाँ पे velocity क्या होगी? At this particular point, what your velocity is just like omega naught. नहीं बोल सकते ना. Omega with which this is actually rotating. So omega times r plus r. Okay. And then something about that. So this means let's just not like that. Think यार क्या में कुछ गलत हो रहा है? No. About this is just the velocity, and then about that it's rotating with. We don't know. This is getting complicated. But they should always follow the contact point, which is rotating around omega naught, of course. So that point should at least be rotating with omega naught, right? Exactly. जहाँ भी touch करने वाला है, that point. हाँ. Oh, then अच्छा तो जब ये touch करेगा then like that is also actually the same thing, right? Because orientation never changes, which means कि it's just translating with it, right? It's not rotating about it. Yeah, that is concept. So it's translating with it. Of course. Yes, that is concept. Okay, तो इसमें still rotation रहेगा, but not like the way we thought. So ये कैसा होगा? Yes, I'm just spending too much time on this thing. तो तुम्हें करना ही पड़ेगा, पर ऐसा invest कर दिया time, अब मैं नहीं रुकने वाला. Just omega naught r. Yes, okay, look. Omega naught r is that velocity of the ring, of our finger, and this is also just translating with it. So the velocity of this guy, okay, that's also just omega naught r in this direction, right? Exactly. Yes. So ये जो point है, this point is going down by omega naught r. That's our contact point. So omega naught small r, that is equal to इसका जो भी omega होगा, that's there, okay. And so इसका जो contact point is like that. Okay, that is right, equal to 0, right? Because it's just pure rolling. So that should have equal to 0. Then this should be omega naught, just that. But then that just becomes that. जो अपन start में सोच रहे थे वही हो रहा है फिर यहाँ पे. So that's our contact point. What if your contact point is rotating with a different thing or something? अच्छा वो इस पे रहने वाला है ना. It is going to be on. That point over there. उन्हें बोला है contact point is just yeah. The fingers in contact is R, right? It's a part is by the point where the ring and fingers come. That is R, right? And we know that that thing is omega naught. So this is also like just omega naught, right? of course. Yeah, that's the thing. Sure. So just translate हो रहा है. That's why that's the same velocity. Okay. फिर अपने करना क्या है? So we just want to figure out the इसके angular velocity about this circle. Yeah, what's that going to be? That should be the same, right? It's just supposed to be omega naught. और वो तो correct नहीं आ रहा है because they are not seems correct unless something else is going on. The ring and the sun contact. मतलब कि okay. At that particular point, that's also just omega naught r. That's this guy's velocity. Okay. So इसके about खुद भी तो वो rotate हो रहा होगा ना, right? So I'm gonna call this like this thing omega of this, right? Wait. Right, the center of mass should also move with omega naught because जहाँ पे वो उसको touch करना है, right? That diameter that also moves like it. So just omega naught capital R, or sorry, capital R minus small r. Okay, I'm starting to make sense now. So with respect to that, it's just omega, right? Yes. So अपना equation just that omega naught r downward is equal to ये तो upward move कर रहा है, so just negative omega naught r as r, and then with respect to this guy, what is happening कि ये ऐसे clockwise move कर रहा होगा, which means कि downward move कर रहा है by negative, oh sorry, positive omega बोलते हैं इसका omega capital R. That looks correct. So मैं उसको तो भेज दो, what do you get? So you still get the same thing that omega is actually equal to omega naught. Okay, so it's rotating about center of mass by omega naught. Okay, cool. So you know, huh? Okay, so omega is in fact just omega naught, isn't it? So by that. So ये अगर omega naught r से move करता है in that direction, and then now it's like, okay, wait, that's not this guy, of course. So ये still stationary point है. That's starting to not make sense suddenly. Ah. Not that, of course. ठीक है ना, just do it half mv square, which is now v is just omega times r, that's r का square. So there we go, omega naught r is r का square, then plus नहीं यार, जो ये अपना नहीं लिखा था वही आ रहा है. once again सेम ही कंफ्यूजन, इसका मतलब है कि क्वेश्चन गलत है, राइट? बिकॉज अपना कंफ्यूजन दो बार सही में आया. ओके, नेक्स्ट क्वेश्चन. यार इसमें सिर्फ टाइम वेस्ट किया. When says 5 questions, each question is okay, जो भी है, correct. I'm sure, pretty sure कि इनमें से कोई भी करेक्ट नहीं है, right? I mean, what else would be the thing? और क्या हो सकता है, right? Okay, next question. Pure water freezes at this thing, and 1 bar addition of this many grams of ethanol and to 500 grams of water changes the freezing point of the solution. Use the freezing constant, depression constant, freezing point depression constant of water as 2. ठीक है ना? The figures show below the okay, plots of paper pressure. Wait, is this chemistry? Huh? Chemistry, right? Okay. This is what? Only one correct. So तो निकालना क्या है? Paper pressure versus temperature में दिया हुआ है. Paper pressure versus temperature. Okay. ठीक है ना? Molecular weight of ethanol is this thing. Answer from the following the option representing change in freezing point is. This is temperature in kelvins. ये है paper pressure. Okay. Of what, by the way? Pressure. अबे किसका पेपर प्रेशर तो बताओ मुझे एटलीस्ट. इथेनॉल का आई थिंक, राइट? ओके, प्रोबेबली इथेनॉल का पेपर प्रेशर, टेम्परेचर. ठीक है ना? सो या लाइक पेपर प्रेशर ऑफ इथेनॉल. सो रॉल्स लॉ इज जस्ट द मोल फ्रैक्शन इन दैट थिंग, राइट? यस, एग्जैक्टली. तुम टेम्परेचर को चेंज करते हो, दिस पेपर प्रेशर चेंजेस समहाउ. हे, आई डोंट थिंक दैट्स द थिंग. वेट, at some certain temperature, but ये क्या हो रहा है? आइस का वेपर, ओके ओके ओके, सो आइस का वेपर प्रेशर इट चेंजेस लाइक दिस थिंग, एंड वाटर प्लस इथेनॉल जो सिस्टम रहेगा उसका, ओके उसका वेपर प्रेशर इज जस्ट दैट, राइट? एंड ये वाटर का वेपर प्रेशर सिर्फ वाटर का ये रहेगा, एंड वाटर प्लस इथेनॉल, ओके सो टिल 273 केल्विन जस्ट वाटर है, उसका वेपर प्रेशर ऐसा दिख रहा है, एंड देन इट चेंजेस टू नाउ आइस, और यहाँ पे बस ओके टेम्परेचर हमारा चेंज हो गया। हाँ ठीक है ना, among the following the correct representation, option representing change in vapor pressure is, wait, as temperature changes what happens to your vapor pressure? क्या था? Okay, natural log of P is equal to R, right? So just our pressure is of what form? It's right, original constant is like uh, okay, E power negative delta H upon RT, so delta H for vaporization, or yeah, okay, so the measure in any case is just positive, sorry shit, negative, तो positive patch अगर, which means temperature increase करने पे ये decrease होगा, right? Yeah, so when temperature increases this should decrease, okay, so then फिर अब ये ice में convert हो रहा है, right? Okay, at this point it's like converting, and then it has converted, right? Okay, and then it's like decreasing as ice का change, that's wrong. I mean it should yeah, so as temperature increases, this should increase as well, because wait, wait, is this increase or what? Temperature increases, तुम्हारा delta H negative delta H 1 RT ना, so that's this should decrease. Oh god, P is of the form A e power negative delta H upon RT. Delta H is negative for both of these guys. As your temperature increases, each is decrease होगी, so your pressure should decrease, I believe. So ये कैसे हो रहा है? Increase हो रहा है इसमें, हाँ? It should decrease in both cases, यार. जो भी, first of all figure out what is this thing, right? 270, 271, 271. Okay. इसको तो मैंने सेम दिखा रहा है. Why is this somehow increasing? Shouldn't it actually decrease? Because मैं कुछ मिस कर रहा हूँ. What am I missing? Uh, okay, उसका ये solute इसमें probably that's also there, but then other than that, pressure versus temperature. It should be a decreasing, yeah. As temperature increases, the pressure should. Wait, but logically it should increase, right? Yeah, because और acceleration होगा. Okay, then maybe this is the correct thing. But फिर ये क्यों नहीं काम कर रहा है for some reason? Delta H. It's an endothermic. Okay, okay, that H positive. Yes. So okay, that explains it. Which means कि C looks correct and B looks correct. I just have to figure out कि ये चीज क्या होगी, नहीं? Okay. So two okay, और molarity क्या है? Okay, ethanol is a CH3COH. नहीं, CH3 CH2OH, sorry, that's ethanol. Okay, which is C2, मतलब कि 2 times of 12 plus 5, okay, which is 6, plus oxygen के लिए just 16, I believe, which is what, 24 plus this is just 30, okay, it's like 46, right? Okay, so just upon 46, 34.5 upon 46, that's the moles. Okay, 500 grams of water, मतलब कि 2 times of this thing is per 1 kg, right? So okay, 34.5 upon 23, this guy is your molality, okay, and this times of 2 calorie, okay, 2 Kelvin, right? Okay, 2 Kelvin kg per mole, okay, got it. ठीक है ना, this is just the thing. तो कितना होगा ये, इसको कैसे करो, just 7879 upon 23. Interesting. Like इसका 3 से multiply just 69 होगा, not 79. What about 4? That's just stupid. So ये तो 3 से काफी, okay, it's like 3 point something, right? 3.5 or something. This is so stupid. I don't know मैं कैसे तो करूँ. It's supposed to be 46 यार. दिमाग काम नहीं कर रहा था. That's 16 over there, of course, because yeah, it's like that's 24 plus 16 is what? So look, better 30 over there. It's just 46. It's 23 over there. 79 upon 23. Yes, I believe so. So just divide. And we have 3 minus 69. यहाँ पे 1 0 आ जाएगा. फिर उसके लिए point. Then you just need 5 or something. Actually 4, 8, and then फिर यहाँ पे well it's like 9, so 3.4 or something, right? Yeah, 3.4 कम किया इसमें से just get 270 के पास में in fact. Yeah, okay, so this should be the thing. I think C. I think C. Next question. 20. For the following cell, when the concentration of Zn is 10 times the concentration of Cu2 plus the expression of delta G in joule per mole is 10 times the concentration of Cu2 plus the expression of delta G in joule per mole is. Okay, Faraday's constant किया है. E cell you gave us क्या है इसमें हो क्या रहा है इसमें copper. So zinc sulfate. This is our like just a positive charge निकलता है, right? So your Cu2 plus is going over there, and then this is your reaction is what? Cu2 plus Cu solid. Okay, so Cu2 plus, okay वो तो भूल जाओ. And what you have over there is like just Zn solid. This gives us Zn2 plus Cu solid, right? Yeah, that's our reaction. Okay, when the concentration of Zn2 plus is 10 times the concentration of Cu2 plus the expression for delta G, okay, is, so क्या delta G is equal to negative NFE, of course. I mean that's the cathode, of course. It has to be the positive one. That's the cathode. Okay, so delta G will be negative NFE. So you can add like what? Yeah, just negative NFE standard. आपने को delta G for, wait, delta G for what by the way? Huh? Okay, wait, this is not going good. Faraday's constant R is ठीक है ना? 1.1. Okay, we'll see. Negative NFE. Okay, already negative आ रहा है. And then plus um, RT natural log of Q, which, what's Q by the way? Concentration of Zn2 plus 10 times the concentration of Cu2 plus, which means कि आप 10 plus square आ जाएगा, right? It's 10 squared. That explains it. So what you get is negative n is like 2 in this case, so just 2. For F, Faraday's constant is, we don't care actually. Which you do. ठीक है just right. अच्छा Faraday में मिलना ना. Okay, just negative 2.2 Faraday plus ये चीज, which probably just want, okay, 2RT natural log 10 upon Faraday times Faraday. So this thing is just 0.06, right? So you get 0.12, I guess. Which is what? Negative 2 point, यहाँ पे just 8 आएगा, फिर यहाँ पे 1 वो मर गया, just 0. So negative 2.08 Faraday or something. Or this thing also works. Wait, नहीं. Okay, this thing also works. B. 2.303. इसमें 2 नहीं चाहिए क्या? हाँ नहीं, सिंगल ही चाहिए, सॉरी, इसमें just 10 चाहिए रहेगा. Yeah, that's the thing. So B is correct. Ending answer B. Next, 21. The standard state gives me energy of formation of graphite and diamond and T equal to this thing. Okay. Standard state means that this जो भी है. The formation of graphite to diamond reduces its volume by this thing if graphite is converted to diamond. Just number that. Okay, the pressure at which graphite is in equilibrium with the diamond is, okay. Okay, the pressure at which graphite is in equilibrium with diamond. So delta G this should be 0, right? That's what you're talking about. Oh god, क्या दिया? conversion of graphite to diamond. Okay, reduces volume by this thing. Okay, so what do you have is dg equal to v minus sdt for each of these states. So integration करें, which is, and we are not changing the temperature, are we? Temperature तो मैं दिया हुआ है, and you are not changing the temperature. Okay, got it. So TD तो भूल जाओ, just basically this thing be TP, right? So yeah, V उनका ऑलमोस्ट सेम रहता है एट एनी प्रेशर, सो दिस डेल्टा V टाइम्स जो भी तुम्हारा चेंज इन प्रेशर तुम कर रहे हो, यस एग्जैक्टली, डेल्टा V मोलर बोलना चाहिए, व्हाटएवर, डेल्टा P ओवर देयर, गॉट इट। एंड ये क्या है, इनिशियल जो हमारा जो डेल्टा G है, सो कन्वर्जन टू, ओके, ऑफ ग्रेफाइट टू डायमंड, राइट, so 2.9 kilojoule per mole is already there, and then wait, is that positive? Of course positive, okay, तो ये 1 बार पर है नहीं, डेल्टा वी कितना है, ओके ओके, this is volume, so delta v is negative, right? Okay, cool. Just negative 2 times 10 power negative 6 in SI units, I believe. This is for delta p. Okay, let's just figure out what delta p is from the ISO. Okay, just one at 1 bar, say, right? Yeah, 1 bar is how much? It's not 1 Pascal. It's I guess it was just 1 torr is 1 liter Hg, and then 1 bar is just 1, okay, atmosphere, right? Yeah. So just 10 power 5 times जो भी पार्ट्स में आएगा 10 पावर 5, ओके, गॉट इट। और फर्स्ट ऑफ ऑल जस्ट फिगर आउट व्हाट डेल्टा पी शुड बी, राइट, या, सो 29 times 10 power 2 upon 2 times 10 power negative 6, that's what delta G is in, so delta P is in SI units, right? Okay, which happens to be 10 power, ऊपर जस्ट क्या ऊपर जा रहा है जस्ट 8, then happens like 14.5 times 10 power 8, so delta P, right, which is like what, 14.5 times 10 power 3 is like 14500 bar approximately, and you are starting off at 1 bar, like 14501 bar, so A is correct with one. Okay, next question. The following combination will produce H2 gas. I don't know. Maybe I do know. Constant HNO3 and AOH, shown metal and NaCN in the presence of air. It's not multiple choice, is it? No, it's single correct. ठीक है ना? Fe metal and constant HNO3, Cu metal and constant HNO3. Look, okay, मुझे अब याद नहीं आ रहा. Whatever. The order of oxidation state of the, okay, यार जो भी है. La la la. I don't care. Okay, one more. The next statement about the surface properties is or are. ये वही एक पर्टिकुलर चैप्टर जो कि मुझे पता नहीं है, राइट, ये पूरा उसी पर बेस्ड है ना। Okay, for a reaction taking place in container in equilibrium with surrounding, the effect of temperature on its equilibrium constant K in terms of change in entropy described by. Okay, for a reaction taking place in a container in equilibrium with its surrounding. Wait, in a container with its surrounding, mass change हो रहा है for some reason. Okay, the effect of temperature on its equilibrium constant in terms of entropy specified. With increasing temperature, the value of K for exothermic. Okay. Huh. So change of its entropy is described. But change of, okay, because entropy. Oh, okay. क्या है? For an exothermic reaction, with changing temperature, the value of K for an exothermic reaction decreases because the entropy change of the system is positive. I don't think that's the way this works, but then चलो जो भी है. The surrounding decreases. Right, like जो delta G अपना, I know I'm not supposed to be using that, but जो भी है. So the reason would be कि तुम heat निकाल रहे हो surrounding से, right? For an analytical process, तो right, okay. So तुम temperature को इसमें change करोगे, right? Okay, so for these two should be at the same temperature or something, and तुम्हारी जो entropy का change है, that should be the maximum. That's what you want, right? Okay, with increase in temperature, the value of K for isothermic reaction decreases. Yes, I believe in that. Because the entropy change of the system is positive. तुम heat निकाल रहे हो, तो फिर positive कैसे हुआ? I understand that. No, it's not positive. With increasing temperature, the value of K for exothermic. Wait, but then No, like delta S must be positive. Like, okay, yes, it has to be positive because तुम heat निकाल रहे हो, so your delta H is negative. नहीं, okay, then it may not even be positive. ठीक है. With increase in temperature, the value of K for endothermic reaction increases. As unfavorable change in entropy of the surrounding increases. So this is the temperature, the value of K for endothermic reaction increases. Yes, I believe in that. और क्या है temperature, the value of K for increases of ये दोनों same ही है. Okay. Because unfavorable change in entropy of the surrounding decreases. So endothermic मतलब तुमको heat surrounding से निकालनी है. So as you change the temperature, तुम increase करते हो temperature को. That means कि surrounding temperature भी तुम increase कर रहे हो of course. तो जो तुम्हारा heat upon T वाली चीज है, right? Okay, that actually decreases. Yes, that's pretty much correct. और जो तुम्हारा delta S है for that reaction और जो भी है, that's actually fixed thing, isn't it? Yes. Okay, okay, awesome. Right. In that particular temperature, it's kind of fixed. So all that matters is कि तुम बाहर से, yeah, okay, that explains it. Because the change in entropy of the surrounding decreases. Yes, so B is correct, I think. That is like a B. Just don't think about it much. Yes, next question. In a biomolecular reaction, the steric factor P was experimentally determined to be 4.5. The correct option among the following is or are. The addition energy of the reaction is unaffected by the value of the steric factor. What steric factor? I don't know. क्या बोल रहे हो? Okay, for the following compound, the correct statements with respect to. Okay, नहीं 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 नहीं. फिजिकल केमिस्ट्री वेयर इज फिजिकल केमिस्ट्री ये तो नहीं है फिजिकल केमिस्ट्री ये भी नहीं है तो मैथ्स आ गया ओह शिट फिजिकल केमिस्ट्री है ही नहीं अरे यार दैट्स नॉट गुड और जो भी है वो काफी कॉम्प्लिकेटेड वाली है ठीक है जो भी है so following will produce H2 gas then a metal NaOH no probably not Fu metal than NaCN I think Fe metal than concentrated HNO3 huh Cu metal than concentrated इट्स एक्चुअली ए वेरी गुड ऑक्सीडेंट तो फिर वो H2 गैस को अपने आप ऑक्सीडाइज करके H2O भी क्रिएट करता है ना यस NaCN in the presence of air how does that produce H2O I don't get it Cu better than concentrated HNO3 iron metal no this does oxidize the iron metal so A probably correct है Cu metal I think A और B है मैं B जा रहा हूँ I don't know correct है कि नहीं है but who cares क्या स्कीम में तुम्हारे में क्या फर्क पड़ता है जल्दी नेक्स्ट क्वेश्चन इन ऑर्डर ऑफ ऑक्सीडेशन स्टेट ऑफ द फास्फोरस एटम इन H2O ऑक्सीडेशन स्टेट ओके कूल ऑफ द फास्फोरस एटम से P2 आ रहा है हाँ एक में P2 है अदरवाइज ओके सो ये तो इजी हो जाएगा राइट क्या यू नो सो ऑक्सीजन के लिए क्या जस्ट 2 टाइम्स ऑफ हर एक में जस्ट 2 माइनस आने वाला है व्हिच मींस दैट इट्स जस्ट राइट सो H में एक वेट phosphorus versus hydrogen right H में प्लस आएगा of course yes so you know like 3 plus है charges और इसमें just 2 times of okay I think we should do it like this -3 plus 2 times of 2 which is 4 so इसमें 1 है okay so पहले से 1 है फिर H3PO4 में of course बढ़ गया because H3 और ये so yeah so H3PO2 लेस देन H3 ओके स्टार्ट मैक्सिमम कितना है H3PO4 का ऑफ कोर्स और ये क्या इसको रिड्यूस करो H2PO3 हो रहा है नहीं इसका ऑक्सीडेशन स्टेट बड़ा रहेगा देन H3PO3 आई गेस कितना है तो H3PO4 का कितना होगा वेट एंड आल्सो बिगर देन H3 ओके ओके so H3PO4 is highest then you have H4 हाँ वो चीज then H3PO3 and then O2 I think that looks correct yeah so C is correct next question let's put C for this it's like H2PO3 which yeah bigger than that major product of the following reaction is NaNO2 HCl 0 degree Celsius aqueous NaOH oh he's just doing that of course right as an salt and then उसके बाद में aqueous NaOH it just forms this guy of course right oh ये थोड़ा सा अलग है oh wait okay coupling कर दी directly so just basically this thing yeah right so I think C might be the thing you know of course Of course. It's gotta be the thing, of course. So C, yeah, 24th का मैं C बोल रहा हूँ. I don't see कि D क्यों नहीं हो सकता, or maybe it can be. Who knows? You can of course like flip this or something. You can do that, right? Yes, you can. और क्या फायदा है ये करने का वर्सेस ये करने का? I don't think so कि उसमें कोई फायदा होने वाला है अपना. दोनों pretty much same kind of complex है, except कि अच्छा ये nitrogen answer. Yeah, that doesn't actually help. It doesn't help in the end. ठीक है, the next question. Order of basicity among the following compounds is. It could also be D though, because अच्छा कहाँ पे अटैक करेगा? What do you think? At this place or at this place? दोनों equally charged है, so I guess para is will attack, of course. So C is correct. Next question. Order of basicity among the following compounds is basicity की order. Okay. Okay, एक इसका H plus कितना? Okay, okay जी. That's acid, not basic. इसमें डालते हो like right कि lone pairs जो है those are in resonance. That's not good. इसके lone pairs भी resonance में है. That's still not good. Okay. It's already having light of kind of positive charge because इसमें yeah. What about this guy? Once again in resonance. What about this guy? इसमें तीन आएंगे, which is once again resonance. हाँ, but यहाँ पे एक extra nitrogen ऐसे ही बस पड़ा हुआ है, which means कि third first आने वाला है, and that's not there for some reason. Okay. Think. अगर मैं इस पे H plus अटैच करता हूँ, then what do you have? मतलब नेगेटिव चार्ज वापस नेगेटिव चार्ज. ओके, इंटरेस्टिंग. सो ये नहीं होगा, बट ये हो सकता है ना. ओके, एंड व्हाट अबाउट दिस गाय? ओके, फिर ये तो इफेक्ट इस पे ज्यादा हो जाएगा नहीं. सो थर्ड लुक्स मोर करेक्ट टू मी और समथिंग. फिर इसकी भी तो रेजोनेंस में है, बट ओके दैट डजंट वर्क लाइक दैट. ठीक है, H प्लस को लेना है. स्केल की फर्स्ट वाला जो है दैट इज बिगर देन 4, सो फर्स्ट बिगर देन 4 फर्स्ट उसमें नहीं है. सो ए और बी में से कुछ तो भी एक करना पड़ेगा. और 3 और 2 के बारे में क्या कर रहे हो? इसमें इसमें ये वाला रेजोनेंस में है. ओके, इसमें एक है, इसमें दो है. या जब भी तुम रेजोनेंस करोगे व्हाट विल हैपन, जस्ट लाइक नेगेटिव चार्ज वहां पे आ जाएगा नहीं. एग्जैक्टली. सो आई गेस थर्ड इज बिगर देन सेकंड. आई डोंट नो. जो एक को चूज कर लो, जस्ट मूव ऑन. ए चूज कर रहा हूँ. नेक्स्ट 26. This is the correct statement about this. Okay. No way. Yeah, I don't want to be doing this. Correct statement. Okay, ये तो अपन कर चुके नहीं. 27. Yes. 28. Biochemical reaction. Okay, steady filter मुझे पता नहीं क्या होता है. The following compound the correct statements with respect to nucleophilic substitution reaction is are 1 and 3 follow SN1 mechanism. Nucleophilic substitution, right? Okay. Yes, it looks about correct. SN1 can happen. 2 not so much. 3 yes. Okay, 1 and 3 for SN mechanism. ये भी इम्पैक्ट कर सकता है. And 4 as well impact. 1 and 2 follow SN2 mechanism. Yes, it can happen. SN2 हो सकता है, but then why would? मुझे चाहिए the correct. So A is correct, B is correct. Upon 4 undergoes inversion of configuration. If SN2 happens, what if SN1 happens? Then it doesn't, right? Yeah. The order of reactivity for 1, 3, 4 is 4, then 1, then 3. Okay. I mean, wait. ऐसा नहीं था क्या कि ये जो चीज है, this is actually like even stronger than this thing? So maybe D is not correct. I don't remember it, but whatever. Configuration. So C is looking correct to me. Wait, नहीं. SN1 हो गया तो this is not. Look. Okay, I don't know. Next question. Among the following, the correct statement is not. This has 3 center 2 electron bonds in its dimeric structure. Dimeric structure. AlCH thrice. Oh yeah, okay. It's like this thing. Aluminium, फिर यहाँ पे aluminium, फिर जो CH3 है, it's, oh wait, but C cannot actually do that, can it? No. 3 center, 2 hydrogen electron bonds, 2 electron bonds. 3 center, 2 electron bonds in its dimeric structure. Huh? Wait, but nahi, it's not that. इसमें hydrogen वगैरह होता, that would actually made sense, but then nahi, that's not there, right? So I don't think it's correct. PhD has 3 centered. Right. So B is correct. 30 का B correct है. Banana bonds, of course. Yeah, this has 3 centered too. Right. So C is also correct. Or is it 3 centered too? Wait. So chlorine की lone pair है. That can go to aluminium. Slightly different, right? So BH3 का structure है तो उसमें like, yeah, okay, borane, of course, diborane. I mean, we have studied for that, but then AlCl3 का बनने कभी ऐसा देखा है क्या? Is it like 3 center 2 electron bond? Yours is lone pair, right? No, that's not quite the thing, actually, right? Yeah. Wait. Like a positive charge imparted. नहीं, ये just coordination है. So for AlCl it's just coordinations. That's not the thing. No. Okay, the Lewis acidity of PCl3 is greater than that of AlCl3. Okay. Lewis acidity of this guy is greater than that of. No, ये अच्छा acid होता है ना? Yeah, so probably not, I guess. I don't think this is correct. Next question. The option with only amphoteric oxides is NO तो neutral oxide होता है ना? So okay, that's wrong already. Then Al2O3 है, PbO है, PbO2 है. I don't remember it. Okay. PeO. PeO is amphoteric. Amphoteric, yes. Okay, that is O. I don't remember. ये amphoteric है. This is okay. CrO. Oh, no, Cr2O3. That's probably not good. I don't think ये सही होगा in that case. So maybe D. C तो ऐसे disqualify हो गया, and then C2R, Cr2O3. That was probably acidic or something, right? CrO was a tin oxide, lead oxide. नहीं यार, ये है एम्फोटेरिक, ये एम्फोटेरिक है आई थिंक. लेड ऑक्साइड PbO2. PbO2 का मुझे नहीं पता. So this is like 3/2 or something in comparison to 1. Okay, like 3. So इसका 2 है. Shouldn't be that big a deal, right? SNO is, we know, just amphoteric. ZNO, I don't remember, probably amphoteric. Okay. और इसका proper 2 है नहीं, इसका 4 है. So that's probably not good. I'm gonna go with B. What about this guy, SNO2? Okay, this is 3 cases. मैं आपको पता नहीं है, right? ठीक है, let's go with D. I don't care. Third one का D. Wait, नहीं, multiple choice है ना, फिर मैं क्यों करूँ इसको गलत? Okay, next. Compound P and R upon ozonolysis produce Q and S. The molecular formula of Q and S is this thing. Q undergoes Konigsberg reaction but not haloform reaction, where S undergoes haloform reaction but not Konigsberg reaction. कहाँ पर P and R? अच्छा, so just give us Q and S. Options with suitable combinations of P and R respectively are. Okay, cool. So P को तुम ozonolyze कर रहे हो, ये कट गया just over there. Wait, you also ozonize the whole ring, of course? Okay, I think so. This forms what? C8H8. Very weird. C8H8. Okay. Molecular formula of this is Q undergoes Cannizzaro reaction, but not haloform reaction with C8, huh? This is like C9 or something. अपने को एक हटाना है, which means of course तुम इसको कट कर दो. If that ever has to happen, then you are just cancelling this guy. And then that's like an aldehyde, ठीक है. So you have to insert an OH group inside, right? Exactly. Maybe hydride shift में करना. Yeah. Wait, no, that wasn't the thing. What you're supposed to do is फिर से एक और OH insert करो and then yeah, okay, do that. फिर वो hydride shift करोगे to actually reduce that guy, of course, and thus forming oxide. Okay, so I guess it's just an aldehyde. It can probably do this thing. Okay, but not haloform reaction. Yes, it does not do haloform reaction. Whereas S undergoes haloform reaction, but not Cannizzaro reaction. R का क्या है? अगर उसको oxidize करते just oh yeah, it does do you know that. But then जब ये तुम करोगे it's like okay okay यहाँ पे हाइड्रोजन है ही नहीं. So that means कि A is correct in fact. So 32 का A correct है. और क्या है? CH3 whatever तुमने ओजोनाइज किया ये कर दिया जब O आ रहा है. That's C8H8 right? या यहाँ पे दो कार्बन यहाँ पे दो कार्बन. यस सो इसको रिलाइज करो जैसे पे ओ आएगा सो दैट अल्डिहाइड. या इट वर्क्स आउट एंड देन फिर इसको तुम कट करोगे प्रीटी मच द सेम स्टफ एज दिस इजंट इट. एग्जैक्टली. सो बी वर्क्स एज वेल. 32 का बी. और क्या है ये चीज. अच्छा तो ये CH3 का पोजीशन चेंज कर रहे हैं नहीं और कुछ नहीं कर रहे लोग. ओके सो हाउ इज दैट इम्पोर्टेंट तो आई डोंट नो. अरे यार ये तो हर जगह पे सेम ही रख रहा है. लाइक ABCD सारे के सारे. That can't be correct. Also, let's say this guy just gives this over there. Internal Cannizzaro reaction. Okay, that's just not going to happen. So ये CH3 की पोजीशन चेंज करने का क्या मतलब फायदा नुकसान कुछ तो मुझे बताओ. आई डोंट नो. फिर मैं ABCD सारे सारे चूज कर लेता हूँ या तो गलत होगा या फिर सही होगा. राइट. नेक्स्ट क्वेश्चन. Okay, X, Y are respective. What is this? Upon heating ClO3 in presence of catalytic amount of MnO2 gas, this is formed. Excess amount of this reacts with white phosphorus to give X. The reaction of X with pure HNO3 gives Y and Z. Catalytic amount of MnO2, a gas W is formed. Of course, ozone. That's for the. No, not ozone. It's like O2 for the pure production of O2, right? Exactly. Yes. So it just forms KClO or something like that. I guess that's the thing. It just forms O2 and then X of O2 reacts with white phosphorus to give P4O10, of course. Yes. Reaction of X with pure HNO3 that gives Y and Z. P4O10 with that gives Y and Z. HNO3 that's just an acid though. H3PO no that's just not working. Probably just H3PO4 और क्या हो सकता है. Unless you're using it as an oxidizing agent, which would mean कि ये actually it's forming H3. Okay, so initially तुम्हारा कुछ तो भी और होना चाहिए था for O6 हो सकता है. I'm pretty sure ये O2 use करता है and yeah, you don't use ozone, you use oxygen, right? Yeah, we use this for production of pure O2, I think. N2O3. Okay, मुझे याद नहीं आ रहा है. It's going to be H3PO4, so it's going to be एक N2O3 or N2O4, right? I guess D. I don't know. Guess करो. What about this guys? O3 and P4O10. O2 चाहिए. I think P4O10 probably. Then इसको और oxidize करो. I think C. So 33 का C कर डाल रहा हूँ मैं. और इसका P4O6 मुझे पता नहीं क्या है. मतलब P4O10 मैंने देखा हुआ है. So I don't know D just because I want to. Okay. Cool. Next question. Okay, reaction of compound P with CH3 MgBr and in CH into the ether followed by the addition of H2O gives Q. Compound Q on H2SO4 at 0 gives R. The reaction of R with CH3 COCl in the presence of anhydrons AlCl3 in CH2L Cl2 followed by H2O produces compound S. Okay, so P तुम्हें दिया हुआ है बढ़िया. So this with CH3 MgBr. Okay, so CO2 COOT. Yeah, okay, it just forms that, of course. So access you are using, huh? Let's just see over there. Just use that problem. एक और insert कर दिया, just OH आ जाएगा यहाँ पे. Yeah, so यहाँ पे क्या just this will just have two Me groups now attached to it, right? Exactly. और यहाँ पे तो कुछ नहीं हो रहा है. Okay. So what's the product S? Reactions Q to R, R to S, whatever. That forms Q. Okay. Compound Q on treatment with H2SO4 and this gives R. Of course, it's gonna form that guy, right? Yeah. Or it could just go to. Nah, that's probably not what's happening. ARSN of that guy, I don't think that's correct. Gives 0 to. Okay, at 0 to 6 is like old. Then okay, ARSN की उतना energy नहीं रहेगी नहीं. Okay, it just forms this thing. So यहाँ पे ये CH3 thrice है, ये अपना benzene ring. And what is this forming? Just यहाँ पे पहले तो Q में just forms दो Me अटक गए, यहाँ पे OH आ जाएगा एक, फिर उसको तुम मतलब just forming a double bond. उसके बाद में क्या? Oh, this is R. The reaction of R with CHC. Okay, so Q to R क्या है? It's dehydration. Yes. Sulfonation. Okay, no. Okay, maybe C. Maybe C. I think it's dehydration though, because 0 degrees Celsius. Okay, so reaction of R with CH3COC in the presence of anhydrous AlCl3 in CH2Cl2 followed by. Huh, that's kind of weird. It's not expecting कि ये ऐसा होगा. What if it's just. Oh shit. What if it's just that? Reaction of R with CH3COCl. Okay. Right. Okay. In the presence of anhydrous ठीक है, just yeah, acylation, right? Followed by the treatment with H2O produces compound S. So just acylation, of course. So dehydration and filter cup acylation. So I think A 36 E. Yeah, I mean it has to filter cup acylation, which is in okay तीनों चारों में है इस फैक्ट तो ठीक है ना, whatever. So what's S going to be? यहाँ पे ये कैसे गया? It's probably just this thing, right? C looks good. ये यहाँ पे क्यों आ रहा है? Because ये तो already statically hindered है, so that should not be happening. ये क्या है गंदी सी चीज? Oh, you are forming that. Okay, okay. As I thought. ये कहीं ना कहीं होगा. That's probably charge over there. हाँ ये होने तो वाला ही था कहीं. Wait, why does it attack over there? Because जहाँ पे अटैक करेगा पॉजिटिव यहाँ पे आएगा यार. तो that's not what we want. We just want. Okay, you already have to condition नहीं कर सकते. There's no point in doing that. But still inductive effect अपन कर सकते हैं ना. So just attack over there, I guess. Okay. Then it's point. Okay. So either it's B and okay, or it's like C. Sulfur क्यों है इसमें? I don't get it. ठीक है ना? But it's at 0 degrees Celsius. I don't see any reason for it to be doing ARSN. But then तुम्हें E2 के लिए भी तो एनर्जी लगती है. So then what should I even do? Positive charge right there. It's starting not make sense. What if it really does ARSN? It could be. It could just be doing ARSN after all. But that's not being heated. तो क्यों मतलब? Okay, whatever. Maybe ARSN है, but maybe मतलब aromatic हो रहा है, but ठीक है जो भी है. So this is it in that case. काफी सारा ना बचा हुआ यार. फिजिक्स का 17 and 18 बचे हुए, वो स्टिल ओके, तो वो वाले क्वेश्चंस हैं. Probably don't have the correct answer. Maths का 44 बचा हुआ है, which is G of equal to this, then okay, G dash of 5.2 and G dash of 5.2, right? लोग ने सारे गलत है. We know that because sin of 2x at pi upon 2 that will, or negative pi upon 2 is just 0. So it should just be like हाँ वो sin inverse of 0 आएगा. It's 0 anyways. First part of the 0 होने वाला in any case, right? और second part में जो डेरिवेटिव आएगा sin x का cosine of x. So जो cosine x का डेरिवेटिव है that like yeah. of course. So वो cosine x का derivative that that becomes 0 in pi upon 2 negative pi upon 2. So it should be 0 in yeah in all cases, but उन्होंने छोड़ दिया है. I know उन लोगों ने कैसा किया होगा that sin inverse of sin 2x को उन लोगों ने just yeah I hate that. उन लोगों ने उसे just 2x put कर दिया होगा and then like 2x minus x. I get that, but that's just stupid. Exactly. So 4 cosine of 2x and then you just have x, right? Minus cosine of x times of x. Just x times 4 cosine of 2x minus cosine of x. अगर मैं इसे pi upon 2 put करता हूँ, what you get is pi upon 2 times 4 cosine of what do I put over there? Just it's like 2. Okay, pi. Okay, negative 4 and then over again just what? Negative 2 pi, right? So then g dash y is negative 2 pi. So 44 का a होगा in that case. It's not correct after all. Okay, or क्या at negative pi upon 2 is just cosine of negative pi, but it's still negative 4. So just 2 pi, positive 2 pi, which is b. So 44 का thing जो भी है. So maths is done completely. फिर से last 2 questions बचे. Chemistry organic chemistry मुझे आती नहीं है. अरे यार ये रिवाइज करके आना चाहिए था नहीं. Okay, whatever. फिजिक्स का 17 और 18 वापस ट्राई कर लेते हैं. उसमें बहुत दिमाग खराब किया मैंने और मुझे इंडियन ये रियलाइज हुआ कि अपनी जो फिंगर है वो रोटेट कर रही है अबाउट इट सेल्फ एज वेल, इसलिए वो ओरिएंटेशन की सेम है. इसमें तो अपना जो कॉन्टेक्ट पॉइंट है दैट्स वेट अ सेकंड. फिंगर का सेंटर मूव कर रहा है ओमेगा नॉट, बट देन द फिंगर इटसेल्फ इज मूविंग सच दैट इट्स ओरिएंटेशन इज नॉट चेंजिंग, राइट? ओके, व्हिच मींस ओमेगा नॉट से वो ऐसे मूव कर रहा होगा, राइट? एग्जैक्टली. सो एट एनी गिवन पॉइंट इसका ओमेगा नॉट नीचे है एंड देन ये जो जहाँ पे कांटेक्ट पॉइंट हो सकता है, हाउ डू यू इवन नो कि यहाँ पे कांटेक्ट पॉइंट होने वाला है? ओह शिट. नो बट ओके लाइक ओके ठीक है ना, सारे पॉइंट्स की वेलोसिटी सेम हो जाएगी, राइट? बिकॉज ओरिएंटेशन इज सेम एवरीवेयर, ऑफ कोर्स. वेट, देन जहाँ भी कांटेक्ट पॉइंट है and it's moving about that. Okay, but oh, अरे यार कहाँ पर है ये? 17 का क्वेश्चन नहीं, फिजिक्स 17 मर गया मैं. शिट 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 शिट. मुझे ऐसा क्यों लग रहा है कि ये एक्चुअली जो फिगर थी वो डिसीविंग है समहाउ. 17 क्वेश्चन या मोस्टली किसी फिगर थोड़ी सी डिसीविंग है, राइट? गेट इट्स लाइक इट्स कॉन्टेक्ट एंड एवरीथिंग, बट देन हो सकता है कि ये एक्चुअल में एग्जैक्टली ऐसा ना हो कि जहाँ पे या ओके दैट माइट नॉट बी द थिंग आफ्टर ऑल. So the center of that guy is like right. What if that is essentially not the way it is actually done? Okay, so अब ये थोड़ा सा ज़्यादा डायरेक्शन पार्ट में जा रहा है which I don't want to be doing. So I'll just leave it there. ठीक है, 6 मिनट बचे. Yes, we should stop for now. Okay, 5 मिनट में कर भी क्या लूँगा. That's it, we'll stop. चलो फिर चेक करते हैं. To internal review, full marks are awarded to all candidates for question 17. मैंने पहले ही कहा था कि वो गलत है, मैंने पहले ही कहा था कि वैसा नहीं हो सकता है. ठीक है. और 18 था. ओ 18 करेक्ट था. अच्छा तो वो क्वेश्चन उसका, बट देन ठीक है ना, आपने 17 समझा नहीं तो फिर व्हाट्स द पॉइंट ऑफ अटेंडिंग 18, राइट? या 44 एंड 45. ओके ठीक है, सो अपना 17 तो करेक्ट हो गया. 44 हाँ वो भी अपन हाँ अपन जानते वो जीरो होना चाहिए, दैट्स नॉट द थिंग. 45 भी फुल मार्क्स दे दिए. आई डोंट नो, शायद से मैंने कुछ सिली मिस्टेक की होगी. जो भी है लेट्स स्टार्ट. ए बी फिर डी है, सो दिस वाज रॉन्ग. फिर ए फिर ए फिर 6 का बी, 7th का बी, 8th का ए बी, 9th ए डी, 10th ए डी, 11th BC, फिर इसका ABC, 13th ACD, सिर्फ C या फिर CD, मैंने BC किया, सो दैट्स रॉन्ग। ठीक है, 15 का A, फिर इसका C, यस। 17 का मैं करेक्ट बिकॉज मुझे ठीक है, 19 का C, 20 का B, 21 A, 22 C चाहिए, मैंने B किया है, दिस इज रॉन्ग। 23 और 24 का C, oh wait, 23 24 का C, okay, and then 25 का भी C, मैंने A किया है, that's wrong। 26 A B मैंने किया नहीं। 27 B D मैंने, okay, एक मार्क मुझे मिलेगा। 30 A B D मैंने एक मार्क, okay। 32 A B एज आई एक्सपेक्टेड, कुछ ना कुछ गलत होने वाला है, दैट्स रॉन्ग। ठीक है, 33 C, फिर 34 का B, oh दैट्स रॉन्ग। ठीक है, 36 का A, फिर 36 का B, सॉरी, वेट व्हाट, 36 का D, दैट्स आल्सो रॉन्ग। केमिस्ट्री में बहुत सारे गलत हुए यार। ओके, मैथ्स C, देन D, देन A, देन D, देन कहाँ पे मर गया, 41 B, 42 का D, 43 B, 44 उन्होंने करेक्ट दे दिया, ठीक है। 45 में उन्होंने करेक्ट दे दिया, सो पता नहीं। 46 का AC, 47 का AD, 48 का BC, 49 का BC, 50 का BD, यस ओके। मैथ्स में पूरा करेक्ट जा रहा है, मतलब उन्होंने इतना इजी सेटअप किया था कि वो, ओके। सो ये मेरा पूरा मैथ्स करेक्ट आ गया, विच मीन्स ऑल 18 क्वेश्चंस करेक्ट। और फिजिक्स में मेरे दो रॉन्ग गए अदरवाइज, और एक मैंने अटेम्प्ट नहीं किया। ओके, सो कंबाइंड मतलब मेरे कितने हैं, तीन, राइट। ओके, 36 माइनस 3, 33 ऑलरेडी आ चुकी है मेरे पास करेक्ट। ओके, सो करेक्ट है, 33 ऑलरेडी आ चुके हैं। और फिजिक्स में हमारे इनकरेक्ट कितने आ रहे हैं, दो। ओके, और क्या हो रहा है, केमिस्ट्री में कितने करेक्ट है, एक दो तीन चार पाँच छः। सीरियसली यार, can't believe this. So मेरे 39 करेक्ट हुए in that case, out of 60, that is pathetic. ओके, मेरे इनकरेक्ट कितने हुए, फिजिक्स में दो, फिर प्लस इसमें एक दो तीन चार पाँच, ओके, सेवन, तो मेरे 7 इनकरेक्ट हुए इन केमिस्ट्री। केमिस्ट्री में 5 इनकरेक्ट है। सी, इसलिए मैं ऑर्गेनिक केमिस्ट्री करता हूँ, मुझे पता है मैं कर नहीं सकता हूँ, मतलब मीन्स कि ओके एडवांस की नहीं कर सकता मैं, वो टाइप का नॉलेज नहीं है अभी तक। ओके, तो ये ठीक है, और क्या, और 5 में मार्किंग, सो एक और एक, तो कि दो, ठीक है। 39 करेक्ट, 7 इनकरेक्ट एंड 2 पार्शियल मार्किंग। क्या मार्किंग सी मैंने इनकी, वही 4 - 2 वाली, राइट, आई गेस यार, तो मुझे दी होगी ना मार्किंग, कहाँ पर है, हाँ 4 - 2 वाली, ठीक है ना, ऑलराइट। सो 39 टाइम्स 4, जो भी 39 टाइम्स 4, फिर -4, फिर +2, एंड ऑल ऑफ दैट अपॉन टोटल जितने करेक्ट चाहिए, विच इज जस्ट कितने करेक्ट टोटल चाहिए, 54, 54 टाइम्स 4, राइट। ओके, सो लाइक व्हाट, 39.5 अपॉन 54, राइट। सो आउट ऑफ 54 मेरे लाइक 39.5 करेक्ट हुए, ऐसा बोल सकते हैं, नॉट गुड, ठीक है। वेट, दैट्स एक्चुअली नेगेटिव, ओके, 38.5 व्हाटएवर। परसेंटेज में कितना रहेगा, कैलकुलेटर, 38.5 on 54. So, oh, 0.7, okay, that's new. आई थिंक मेरा मैथ्स का सारा करेक्ट हुआ है, इसलिए शायद से हुआ है, और फिजिक्स में थोड़े से कम इनकरेक्ट है यूजुअल से। सो मेरे 0.7 परसेंटाइल आ रहा है, वॉट एवर। ओके देन, आई गेस वी शुड स्टॉप फॉर नाउ, सी यू गाइस इन नेक्स्ट वीडियो।